What if the answers to humanity's greatest riddles lie not in the stars, but buried beneath miles of ancient ice? Long before the rise of empires, before the first written word, Earth was locked in a frozen stillness, an age where glaciers moved like living giants, reshaping the world in silence. But within this icy past are fragments of truth that don't quite fit. Submerged forests preserved in perfect condition, enormous structures beneath the ice of Antarctica, tools, bones, and footprints discovered in places where humans, according to science, should never have been. Could a forgotten civilization have walked this frozen earth before us? Why did the mammoths die out so suddenly, as if erased overnight? And what force, what unimaginable event, melted ice sheets that had stood for millennia? These are not just whispers of conspiracy. These are questions carved into stone, locked in ice, waiting for someone to listen. So sit back, relax, and prepare to journey into a world where science meets mystery, and the past is far colder and far stranger than we ever imagined. Let's dive in. The silence of the Arctic night is deep and endless. Wind whispers over ice sheets that stretch like ancient monuments to a forgotten time. Beneath the permafrost and frozen soil lies a story that continues to challenge the foundations of modern science. A moment, a shift, an end, to an age that should have lasted far longer. Roughly 12,900 years ago, Earth was plunged back into a deep freeze. Just as the planet was beginning to thaw from the last glacial maximum, temperatures across the northern hemisphere dropped suddenly and dramatically. It was the beginning of what scientists now call the Younger Dryas, a brief but intense return to Ice Age conditions. Across Europe, Asia, and North America, glaciers surged, forests withered. Megafauna like the woolly mammoth and saber-toothed cat faced the final chapter of their existence. And then, as suddenly as it began, it ended. Around 11,700 years ago, global temperatures rose abruptly. Some records suggest as much as 10 degrees Celsius within a matter of decades. Ice retreated. Sea levels surged. And in the wake of this transformation, human civilization began to stir. Agriculture, permanent settlements, monumental architecture, all emerged in this narrow window of newfound climate stability. But the question remains: what caused the Younger Dryas to end so suddenly? Mainstream climatology has long sought answers in the rhythm of Earth's orbit, the shifting of ocean currents, and the dynamics of atmospheric greenhouse gases. One prevailing theory is the meltwater pulse hypothesis, a sudden influx of fresh water, perhaps from the catastrophic drainage of North American glacial lakes like Lake Agassiz into the North Atlantic. This torrent may have disrupted the Atlantic meridional overturning circulation, AMOC, a system of ocean currents that plays a key role in regulating climate. With the circulation weakened or shut down, warm tropical waters failed to reach the north, triggering a deep chill. But if meltwater started the Younger Dryas, what then brought it to such a swift end? Did the AMOC restart on its own? Did some other global mechanism reassert itself? As climate scientists examine ice cores from Greenland and sediment layers from the ocean floor, they search for the moment, faint chemical traces, sudden shifts in isotopes that mark the end of this period. The records are clear. Something changed, and it changed quickly. Yet, for all our models and simulations, there are signs that something more unusual may have occurred. One of the more controversial but intriguing ideas is the Younger Dryas impact hypothesis. According to this theory, around 12,800 years ago, Earth may have collided with fragments of a disintegrating comet. This impact, or series of impacts could have triggered massive fires, sent debris into the atmosphere, and led to a sudden cooling, a global impact winter. Melted nanodiamonds, microspherules, and elevated levels of platinum have been found in sediment layers at sites around the world. Evidence, some suggest, supports this theory. Could the same forces that triggered the Younger Dryas have also been responsible for its end? Perhaps the aftermath of an impact destabilized ice sheets so dramatically that it ultimately flooded the oceans with enough cold water to shut down the climate system temporarily, only for the system to roar back once that disruption passed. There are even more speculative interpretations. Some researchers have pointed to ancient oral traditions, indigenous stories of fire from the sky, floods, and darkness. In places like the Americas and the Middle East, including regions like Palestine, where some of humanity's earliest cities would later rise, there are myths that hint at global catastrophe and rebirth. Are these just symbolic tales, or faint echoes of an event our ancestors witnessed firsthand? At Göbekli Tepe, in southeastern Turkey near the border of modern-day Palestine, megalithic structures dated to roughly 11,000 BC stand in silent defiance of conventional history. Carvings there, some argue, may reference celestial events or cosmic disasters. Could this site, a product of a pre-literate, supposedly primitive culture, have been a response to a traumatic environmental shift? Was it a sanctuary, a temple, or perhaps a memorial to a vanished world? The end of the Younger Dryas also marks a period of sudden innovation. The Natufians, hunter-gatherers living in the Levant, began to experiment with cultivating wild grains. Farther east, the first signs of irrigation and crop domestication appear. Across the globe, cave art, monuments, and early tools all reflect a species emerging from something, awakening, perhaps, from a long slumber forced by nature's wrath. Coincidence? Or consequence? Even now, the Earth's ancient memory is incomplete. Ice cores melt, sediments shift, and human activity erases what little remains of those first fragile traces. What we know is this: something ended the Younger Dryas. Not slowly, not predictably, but with a rapid, irreversible force, a tipping point in the story of Earth, a moment when chaos yielded to order and cold gave way to warmth. We stand in the warmth of that outcome, building our world atop its legacy. But do we truly understand what came before? Could it happen again? The mystery of the Younger Dryas end remains unsolved. Perhaps the answer lies deep beneath Greenland's ice, or encoded in the myths of a forgotten people, or scattered among the stars, where ancient comets still wander. For now, all we can do is ask and wonder what else is waiting to be uncovered. As Earth emerged from the cold grip of the Younger Dryas, something else was vanishing, something that had walked this world for millennia, shaping the landscapes and outlasting entire epochs. In the remote stretches of Siberia, where the wind carves through snow like a blade, there are places where time stands still. Beneath layers of frost, the remains of a giant lie perfectly preserved. Long, curved tusks reach toward a sky they will never see again. Thick, shaggy fur still clings to leathery skin. Teeth, worn from a lifetime of grazing, are clenched tight, as if frozen in their final breath. This is a mammoth, or more accurately, what is left of one. The mammoth was more than a creature of its time. It was a symbol of the Ice Age itself. Towering, resilient, and remarkably adaptable, mammoths roamed from the grassy mammoth steppe of Eurasia and North America to the windswept islands of the Arctic. For over 400,000 years, they thrived. And then they were gone. The extinction of the mammoths is not a single event, but a pattern, staggered, uneven, and strangely timed. Across much of the world, mammoth populations collapsed around 10,000 BC, shortly after the Younger Dryas came to a sudden end. But isolated groups survived much longer. On Wrangel Island, north of Siberia, a small population endured until around 2000 BC, contemporary with the Egyptian pyramids. Why did these mighty animals vanish? What chain of events brought down a species that had survived multiple ice ages before? Science offers several plausible answers, but none are complete. The most widely accepted theory is climate change. As Earth rapidly warmed at the end of the Pleistocene, grasslands began to shrink. Forests expanded. Wetlands formed. The vast, cold steppes that once sustained large herds of mammoth and other megafauna, like giant ground sloths and woolly rhinoceroses, were replaced by ecosystems less suited to such enormous grazers. It's a compelling explanation, but it leaves questions. Other animals adapted. Bison and elk continued to flourish. Some species even expanded their range. So why not the mammoths? Could human activity have played a role? As Homo sapiens spread across the globe, they brought with them new tools, new strategies, and new pressure on ecosystems. Evidence of mammoth hunting exists across Europe, Asia, and North America. Spears embedded in mammoth bones. Massive bone piles suggesting mass kills. Intricate cave art in places like France and Palestine depicting mammoths in astonishing detail, perhaps as prey or perhaps as myth. The overkill hypothesis suggests that early humans, armed with coordinated tactics and an insatiable need for resources, may have hunted the mammoth to extinction. Not through malice, but through simple success. In this view, it wasn't one great catastrophe, but thousands of small ones. Villages feeding on the herds, families surviving one winter at a time. Yet even this theory fails to capture the full story. In regions where mammoth populations were small and isolated, like the Arctic islands, the animals survived for thousands of years after humans arrived. And in places with minimal human presence, mammoths still disappeared. So, if not climate alone, and not hunting alone, what else? Here is where the story shifts from scientific to speculative. Some researchers propose that mammoths fell victim to disease, a fast-spreading pathogen carried by migrating humans or other animals. With populations already stressed by changing environments, a virulent illness could have been the final blow. But there's little physical evidence to confirm such a plague. Others look to the skies. As discussed earlier, the Younger Dryas impact hypothesis suggests a cosmic event, perhaps a comet or asteroid, struck Earth around 12,800 years ago. The resulting firestorms, debris clouds, and climate shifts could have triggered mass extinction. In this theory, mammoths died not by human hands or warming skies, but by fire and ice falling from the heavens. Supporters point to a strange layer of sediment found in several locations, darkened earth laced with iridium, nanodiamonds, and microscopic spherules. Some of these are found near mammoth kill sites. Coincidence or aftermath? There are even more radical ideas. Alternative theorists have proposed that the mammoth's extinction was part of a broader reset, one of many cycles of destruction and rebirth hidden in the geological record. In this view, lost knowledge, ancient civilizations, and global catastrophes are linked, not by myth, but by long-forgotten science. They cite supposed fossil evidence, unexplainable tools found near mammoth remains, and enigmatic ancient carvings that hint at astronomical alignments. Some even suggest that humans and mammoths may have had a deeper relationship than simple predator and prey, that we lived alongside them in ways we no longer remember, that perhaps their disappearance wasn't entirely natural or accidental. These ideas remain controversial, even fringe, but they endure, not because they offer definitive answers, but because the mainstream ones remain incomplete. And still, the permafrost continues to thaw. Each year, more mammoth remains emerge from the ice, some so well preserved that scientists have harvested DNA, muscles, even blood. There is talk of resurrection, of bringing the mammoth back, not as a symbol of extinction, but of renewal. But even if we succeed in cloning one, will we ever truly understand why the original disappeared? The extinction of the mammoth is not just a scientific puzzle. It is a story of survival, loss, and deep mystery. A species that endured the coldest of times, gone, almost without warning. And with them, a piece of Earth's untold history vanished beneath the snow. Could we be missing something fundamental? Something buried deeper than bone? As we uncover more of their frozen legacy, the mammoth may still have secrets to share. But for now, the wind across the tundra carries only silence, and the fading echo of footsteps too large to be forgotten. Transitioning from the mystery of the mammoth's extinction, we now turn our attention to a thin, dark band in the soil. A boundary in time, silent and strange, stretching across continents. It is neither bone nor tool, but it speaks of something profound. A moment when the world may have changed forever. Across the ancient plains of North America, from Arizona's desert canyons to the grassy meadows of South Carolina, and even into parts of Palestine, archaeologists have uncovered a peculiar layer of soil, a thin, black, carbon-rich mat buried just beneath the surface. To the untrained eye, it's unremarkable, a dark stain on the land. But to those who study the deep past, it is a marker of something extraordinary. Roughly 12,800 years old, this black mat appears abruptly in the geological record, coinciding with the sudden cooling of the Younger Dryas, the extinction of Ice Age megafauna like the mammoth, and the disappearance of the Clovis people, one of the earliest known human cultures in North America. What caused this layer? Why does it appear in so many places, all dated to the same narrow window of time? And what does it truly represent? Mainstream science offers a cautious explanation. The black mat, in many cases, is thought to be the result of slow-forming organic accumulation, layers of plant material, algae, and silt deposited in wetlands during a period of climatic instability. As the Earth cooled, the black mat may have formed under waterlogged conditions, preserving organic matter in a fine, dark band. In this interpretation, the black mat tells a story of retreating glaciers, changing ecosystems, and rising groundwater levels. A natural response to the chaos of a shifting world. And yet, not all the evidence fits so neatly. In some locations, the black mat is laced with anomalies, microscopic spherules, nanodiamonds, and traces of rare elements like iridium, materials typically associated with high-temperature events, like cosmic impacts or massive fires. These are not substances we expect to find in quiet wetlands. They speak of heat, pressure, and sudden transformation. At sites like Murray Springs in Arizona and Topper in South Carolina, this layer sits directly above the last remains of mammoths and other Ice Age creatures. No Clovis tools are found above it, only below. It is as if the layer marks an abrupt and irreversible end. A line in the earth that says, before this, life as we knew it, after, something else entirely. This has led some researchers to propose a bold theory, that the black mat is a global layer of catastrophe, the result of a cosmic impact that struck Earth at the onset of the Younger Dryas. A comet or fragments of a disintegrating body, perhaps from the torrid meteor stream, may have exploded in the atmosphere or impacted the ice sheets themselves. The force of such an event would have been unimaginable. Shockwaves, heat, widespread wildfires, and a plume of debris launched into the upper atmosphere. The impact could have triggered the sudden cooling observed in climate records, started massive floods from destabilized ice sheets, and led to the collapse of ecosystems and human cultures. Supporters of this Younger Dryas impact hypothesis argue that the black mat is the fingerprint of this disaster, that its carbon-rich composition, its unusual geochemical markers, and its synchronicity with extinction events all point to something beyond the gradual workings of nature. Yet the theory remains controversial. Critics argue that the spherules and nanodiamonds found in some sites may have other origins: volcanic activity, lightning strikes, or industrial contamination. Others maintain that there is insufficient evidence for a single global catastrophe, and that localized events may have created the black mat through more mundane processes. But the pattern persists. From North America to parts of Europe and the Middle East, including regions of ancient Palestine, black mat layers appear with striking consistency. In each case, they seem to coincide with a broader transformation of climate, of wildlife, of human behavior. Coincidence or consequence? Some researchers have explored more unconventional interpretations. Could the black mat represent a planetary reset, triggered not by a comet but by Earth itself? A volcanic eruption of unprecedented scale, a sudden surge in solar activity, or a magnetic pole reversal? Ancient myths across cultures speak of fire and darkness, of floods and falling stars. Could these be memories, not metaphors, of the same event marked in stone? There are even stranger ideas. Some suggest the black mat is the residue of technology, evidence of firestorms or atmospheric events unleashed by an advanced civilization lost to time. While there is no direct proof to support such claims, the notion lingers at the fringes of the academic debate, reminding us how much of human prehistory remains unexplored. What cannot be denied is the symbolic weight of the black mat, a thin line of darkness in the earth, separating two worlds, one teeming with mammoths and mastodons, Clovis hunters and giant sloths, and one without them. Above it, the beginnings of a new age. Below it, a vanished world. Even now, as geologists sift through ancient sediments and archaeologists brush away layers of time, new questions emerge. Why do we find similar materials in such far-flung places? Why did so many species vanish so abruptly? And what truly caused the climate to spiral into chaos at the very moment this layer was formed? The answers remain elusive. The black mat speaks, but only in whispers. In the end, it may not be a single explanation that solves the puzzle, but a web of causes, each thread linked to the others in ways we have yet to understand. For now, this dark ribbon in the soil remains one of the clearest and most haunting signatures of a forgotten crisis. A warning etched in earth, a mystery still waiting to be fully read. And the deeper we dig, the more we must ask, what else lies hidden just beneath the surface? As we leave behind the charred sediments of the black mat layer, we follow the trail of clues across the shifting landscapes of deep time. One such clue stretches across the eastern United States, not in the form of ash or bone, but in shallow, elliptical depressions, carved into the land like faded fingerprints from a vanished hand. They are silent. They are countless, and they are unlike anything else on Earth. Stretching from Delaware to Georgia, and concentrated most heavily across the Carolinas, the Carolina Bays are a vast collection of enigmatic landforms. From the air, they appear as smooth, oval shapes, some barely noticeable, others spanning miles, each one tilted on a remarkably consistent northwest-southeast axis. They number in the hundreds of thousands. Their edges are raised. Their floors often collect water, forming seasonal wetlands and ponds. And for over a century, they have baffled geologists, historians, and scientists alike. What carved these features into the earth? What force shaped them so uniformly over such a massive area? And why do they appear nowhere else on the planet? Mainstream geology has long grappled with these questions. Some researchers suggest that the bays are the result of wind and water erosion formed in the waning years of the last ice age. In this view, as permafrost melted and winds swept across loose sediments, shallow depressions gradually took shape, smoothed and sculpted by countless years of weathering. Their consistent alignment, some argue, may be the result of prevailing ice age winds, channeling through glacial outwash plains. This explanation, while elegant, struggles under the weight of scale and precision. How could natural winds, uneven, shifting, unpredictable, create tens of thousands of identically aligned, uniformly shaped depressions across such a vast region? And why do similar wind-formed patterns not exist in other parts of the world with similar ice age conditions? The problem deepens when we look below the surface. Studies of the Carolina Bays have revealed something curious. Beneath the layers of peat and organic matter that have collected since the end of the Ice Age, the original sand rims of the bays remain sharply defined. Radiocarbon dating suggests that these rims are older than 10,000 BC, placing their formation near the very time of the Younger Dryas onset, the same period marked by the black mat layer, the megafaunal extinctions, and abrupt climatic upheaval. Coincidence? Or part of a larger interconnected event? Some researchers believe the Carolina Bays hold the key to one of the most controversial scientific debates of our time. In the early 20th century, some geologists proposed that the bays were the result of a meteor shower, a cluster of comet fragments striking Earth in a massive fragmented impact event. In this scenario, icy bodies entered the atmosphere at a shallow angle, exploding above or just beneath the surface, creating shallow depressions in the soft, post-glacial Earth. The consistent alignment of the bays, pointing northwest to southeast, would then be explained as the entry trajectory of these cosmic fragments. Supporters of this impact theory point to similar formations in the Nebraska rainwater basins, which align toward the same vector as the Carolina Bays, suggesting a widespread, directional phenomenon. They also note the absence of impact craters and hard rock, arguing that if the objects were low-density, icy bodies, they would have exploded in the atmosphere or disintegrated in soft terrain, leaving no traditional crater but scattering energy across the landscape. Could the Carolina Bays be the scars of such explosions? The remnants of an airburst event akin to the Tunguska explosion of 1908, but on a continental scale? Others suggest the bays are part of a much broader cataclysmic pattern, tied to the same Younger Dryas impact hypothesis that some believe created the black mat layer and triggered sudden global cooling. And here, the mystery deepens once more, because the idea of a fragmented comet striking Earth, scarring the land, triggering fires, sending a plume of particles into the atmosphere, isn't merely science fiction. It's a scenario that has precedent in both the geological and astronomical records. The Earth passes through the torrid meteor stream twice each year, a trail left by a disintegrating comet. Some researchers suggest that around 12,800 years ago, Earth may have passed through a dense portion of this stream, leading to a barrage of cosmic debris impacting the planet. But critics argue there is no definitive proof. No impactor has been found, no layer of shocked quartz or unmistakable crater. They caution that correlation is not causation, that the bays may have formed gradually or through processes we still poorly understand. Still, the questions persist. Why are the bays so consistent in shape and alignment? Why do they appear clustered in regions rich with other Ice Age mysteries, near black mat layers, near extinct megafaunal remains, near Clovis archaeological sites? And why do some Native American oral traditions speak of fire falling from the sky, of thunder without clouds, of a long winter that began in an instant? Like the mammoths, like the black mat, the Carolina Bays may be a silent chapter in a much larger story, one written not in ink but in earth and stone. They stretch across the landscape like forgotten script, perhaps waiting for the right lens, the right question, to make sense of them. Some see in their curves the echoes of catastrophe. Others, the artistry of slow, natural processes, and still others, a message, left by a world on the edge of transformation. In the end, we are left with patterns, with shapes that should not exist, but do. What force shaped them? Was it wind, water, ice, or something far older and far more sudden? The Carolina Bays remain. Quiet, unyielding, markers of a mystery that may connect fire in the sky, a vanished species, and a cooling world into one extraordinary moment in Earth's past. Perhaps the answers are already written there, waiting for us to see them. From the quiet scars of the Carolina Bays, the mystery deepens. We widen our view, not just to one region or one species, but to a global disappearance. A vanishing so vast, so synchronized, that its true scale still escapes casual observation. It was not the loss of a single creature or the passing of a single age. It was a mass exodus of giants, sudden, widespread, and, to this day, unexplained. In the dry grasslands of Argentina, bones of the towering Glyptodon, an ancient armadillo the size of a small car, lie scattered beneath layers of sediment. In the American Midwest, remains of short-faced bears and saber-toothed cats emerge from tar pits and riverbeds. In the vast tundra of Siberia, tusks of mammoths twist up from melting permafrost. And in the once forested stretches of Australia, fossilized skulls of Diprotodon, the largest marsupial to ever live, rest half buried in stone. Across 6 continents, in ecosystems as diverse as deserts, swamps, and highlands, the pattern is the same. Megafauna, large-bodied animals over 100 pounds, suffered sudden, severe extinction near the end of the Pleistocene, between roughly 15,000 and 9,000 BC. It was as if the Earth drew a curtain across a previous act of life and began anew. Scientists have long studied this global megafaunal die-off, and various explanations have been proposed. Yet none fully account for the scale, speed, and simultaneity of the losses. One prevailing theory points to climate change. As the last ice age waned, the world warmed rapidly. Glaciers retreated. Rainfall patterns shifted. Ecosystems were disrupted, and food sources diminished. Large animals, with slower reproductive rates and greater resource needs, may have struggled to adapt. It is a sound theory, logical, evidence-based, but not without flaws. After all, these animals had survived previous climate swings. The Pleistocene was a time of repeated glacial advances and retreats, and megafauna had thrived throughout. So why this time? Why this particular transition? Another theory, equally prominent, is human overhunting. As modern humans spread out of Africa and across the globe, they encountered animals that had never seen upright predators with stone-tipped weapons and coordinated tactics. In North America, the Clovis people left signs of mammoth hunts. In Palestine, as in parts of Europe, early humans painted large mammals on cave walls, creatures they likely depended on for food, tools, and clothing. According to the overkill hypothesis, it wasn't a single massacre but a slow unraveling. Herds thinned, populations dropped below recovery thresholds. One by one, the giants faded from the land. And yet, not everywhere. In Africa and parts of tropical Asia, large mammals survived: elephants, hippos, rhinos, lions. These were regions where animals evolved alongside humans, perhaps learning over time to avoid them. But elsewhere, in Australia, the Americas, northern Eurasia, the megafaunal loss was severe, abrupt, and seemingly unbalanced. Some scientists suggest a blitzkrieg model, where rapid colonization by humans led to swift ecological collapse. But in places like South America, extinction patterns don't always match human migration timelines. In parts of Australia, megafauna may have vanished before clear signs of widespread human presence appear in the archaeological record. The timelines are tangled, and the story refuses to resolve itself. Into this space of uncertainty step more speculative ideas. Some researchers return once again to the Younger Dryas impact hypothesis. If a fragmented comet or asteroid exploded in Earth's atmosphere around 12,800 years ago, it could have triggered massive fires, widespread habitat loss, and a sudden drop in global temperatures. In this scenario, the combined shock of environmental trauma and human hunting pressure may have created the perfect storm, a convergence of natural and human-driven forces too great for the megafauna to survive. Supporters point to geochemical markers found in megafaunal kill sites, unusual concentrations of platinum, high-temperature melt glass, and carbon spherules, suggesting that some of these animals may have died not only from hunting or starvation, but from exposure to intense heat and environmental chaos. Could a single event, or a series of impacts, have initiated a chain reaction across multiple continents? Others explore more fringe possibilities. Could ancient diseases, carried unknowingly by migrating humans or animals, have spread quickly through dense megafaunal populations? Could solar events, like massive solar flares or geomagnetic storms, have disrupted migration patterns or damaged the ecosystems on which these giants depended? And there are still stranger suggestions that Earth passes through cycles of cosmic interaction, periodic bombardments from comet debris streams, or gravitational anomalies influencing climate and geology on a global scale. These ideas sit at the edge of current science, but they are rooted in the genuine mystery of what the fossil record reveals and what it does not. Because for all we know about the last ice age, what remains unresolved is this: how did so many species, across so many environments, vanish in such a narrow window of time? Consider this. Before the end of the Pleistocene, the world teemed with giants. Mastodons roamed North America. Giant kangaroos bounded across Australia. Massive ground sloths towered over the Amazon. Then, over just a few thousand years, a blink in geological time, nearly 75% of Earth's large mammals were gone. We know they lived. We know they died. But the how and the why remain elusive. In the quiet layers of cave floors and lake beds, we find their bones. In the myths of indigenous peoples, we hear echoes of great beasts, of earth-shaking thunderbirds and ancient monsters. And in the questions scientists still debate, we glimpse the edges of an event that may have reshaped life on Earth forever. Were we, as a species, simply the final pressure point? Or did we arrive at the end of something already unraveling? The global megafaunal die-off is more than an ecological mystery. It is a riddle about ourselves, our origins, our impact, and the fragile thread that connects life to time. And as more fossils surface and new technologies reveal what was once hidden in stone and ice, we may find answers, or we may uncover even deeper questions, still buried in the silence of a vanished world. In the windswept plains of New Mexico, beneath layers of time and sediment, a slender fluted point lies embedded in the soil. Carved from stone with almost mathematical precision, it is sharp, symmetrical, elegant in its simplicity, and unmistakably human. This is a Clovis point, the signature artifact of one of the earliest known cultures in North America. And yet, like the megafauna they once hunted, the Clovis people themselves would vanish. Quietly, without warning, and without a trace. Around 11,500 BC, Clovis culture emerged suddenly across vast swaths of North America. from the arid deserts of the southwest to the eastern woodlands, and as far north as present-day Alberta, sites bearing their distinctive tools and weapons appear in remarkable concentration. Their fluted spear points, designed for hunting large game like mammoths and mastodons, suggest a people deeply attuned to the rhythms of Ice Age life. For decades, archaeologists considered the Clovis to be the first Americans, having crossed a land bridge from Siberia into Alaska, then spreading southward as the glaciers receded. But whether they were truly the first, or merely one of many early cultures, has become an ongoing debate. What is more certain is this: the Clovis did not last. By around 10,800 BC, just a few hundred years after their initial appearance, the archaeological record grows suddenly quiet. Clovis sites cease, their tools disappear, and their story becomes a void. What happened to them? The most conservative explanations are rooted in environmental change. The abrupt shift at the end of the Younger Dryas, a warming period following a deep freeze, may have altered the Clovis world beyond recognition. As megafaunal populations crashed, the Clovis way of life, centered around big game hunting, could have collapsed with them. Lacking stable food sources, groups may have dispersed, adapted, or merged with emerging regional cultures. In this interpretation, the Clovis did not vanish entirely, but instead evolved into something new. Archaeological evidence suggests that post-Clovis tool traditions, such as Folsom, Dalton, and other Paleo-Indian complexes, emerged soon after. These cultures made smaller points, likely designed for hunting faster, more elusive prey such as deer or bison. A cultural adaptation to a changing ecosystem. But this transition, if it was a transition, is strangely quiet. There is no gradual shift in artifact styles, no layered overlap. Clovis points end, and others begin, as if separated by an invisible boundary. Could there have been something more? A growing number of researchers consider a more catastrophic possibility. We return again to the Younger Dryas impact hypothesis, the idea that a cosmic event, perhaps a comet fragment or airburst, struck Earth around 12,800 years ago, triggering widespread wildfires, rapid climate change, and the collapse of ecosystems. In some versions of the theory, this event is proposed as the cause of the megafaunal extinction, the sudden cooling and, crucially, the disappearance of the Clovis. At several Clovis-associated sites, including Blackwater Draw in New Mexico and Topper in South Carolina, researchers have uncovered a thin layer of carbon-rich sediment directly above the last Clovis artifacts. Often dark, sometimes rich in soot, and occasionally containing exotic materials such as microspherules, magnetic grains, and nanodiamonds, this layer has been likened to the previously discussed black mat, a possible signature of global catastrophe. Could the Clovis have been wiped out in a single moment? Or did they suffer a slow collapse in the aftermath of environmental trauma? Some speculate that the impact, or series of impacts, may have ignited continent-spanning wildfires. The resulting smoke could have blocked sunlight, leading to sharp temperature drops, an impact winter. Food chains would have been disrupted. Mammoths would have perished, and the Clovis, reliant on both, would have followed. Still, critics argue that no definitive impact crater has been linked to this event, that many of the supposed impact markers are found inconsistently or have alternative geological explanations, that the fall of Clovis culture, while sudden, could still be the result of multiple converging pressures. But what cannot be dismissed is the suddenness, the completeness. Clovis sites do not appear to evolve. They vanish. Their technology does not gradually fade. It is replaced. Their social structures, beliefs, even language, if such things could ever be known, have left no lasting record. Did they die out? or were they absorbed? If so, by whom? Further complicating the story is the question of pre-Clovis presence. In recent decades, sites such as Monteverde in Chile, Meadowcroft Rock Shelter in Pennsylvania, and Cactus Hill in Virginia have challenged the long-held belief that Clovis were the first. These sites, some dating back to 16,000 BC or earlier, suggest that humans may have been in the Americas long before Clovis ever appeared. If true, then Clovis was not the beginning of American prehistory, but a chapter within it. A chapter that rose with surprising speed and ended just as abruptly. Could Clovis have been a high point? A refined expression of earlier knowledge, perhaps brought together during a rare window of environmental opportunity? If so, what caused it to unravel? Other, more speculative theories suggest the Clovis were impacted by cosmic radiation, volcanic eruptions, or even socio-cultural collapse triggered by internal conflict or resource scarcity. Some fringe theorists point to legends and myths of great floods and fire from the sky, tying these oral histories to possible ancient disasters. But without more definitive evidence, such claims remain in the realm of possibility, not proof. What we are left with is a moment of silence. The Clovis people walked this land. They hunted, they crafted. They left behind tools that still cut after 12,000 years. And then, they were gone. No cities, no temples, no great monuments. Only stone, only absence. The disappearance of the Clovis is more than an archaeological puzzle. It is a story of fragility, of how even the most widespread and technologically adept cultures can vanish from the earth in the blink of a geological eye. What echoes did they leave in those who came after? What knowledge was lost in the silence? And most haunting of all, could their fate someday mirror our own? As we sift through the soil, uncovering points of flint and fragments of time, we are reminded how little we truly know of those who came before, and how much still waits, buried beneath our feet. From the vanished trail of the Clovis people, we turn now toward the vast wind-blasted tundra of northern Siberia, a land where time seems suspended, sealed beneath frost and silence. But in recent years, something has begun to stir beneath the ancient permafrost. Something violent, something unexpected. In the Yamalo-Nenets region of Russia, far above the Arctic Circle, helicopter pilots flying over the tundra have reported eerie, gaping holes in the earth. Massive craters, some as wide as 100 feet, their jagged rims carved with explosive force. The surrounding ground is often scorched. Clumps of ejected earth lie scattered in a wide ring, as if the land itself erupted from below. Locals, including the indigenous Nenets reindeer herders, speak of strange booms, deep, thunderous cracks echoing through the empty landscape. Some refer to these features as dragon's mouths or Earth's breath. Scientists, meanwhile, have simply called them permafrost craters, though few can agree exactly what they are or why they're appearing now. These craters are not remnants of ancient times. They are new, emerging within the past decade. The mystery lies not just in their scale, but in their timing and their possible connection to events long buried beneath the Ice Age. The dominant theory is that these craters are the result of methane gas explosions. Beneath Siberia's frozen soil lies a vast store of organic material, frozen plants, animals, and ancient microorganisms, trapped for tens of thousands of years in the permafrost. As global temperatures rise and the permafrost begins to thaw, this material decomposes, releasing methane, a potent greenhouse gas. In certain conditions, pockets of this gas build up pressure beneath the frozen surface, especially when sealed under layers of ice or dense soil. When the pressure becomes too great, the ground can erupt in a sudden explosion, hurling debris into the air and leaving behind a deep cylindrical cavity. It's a logical explanation, one supported by satellite imagery, gas readings, and field investigations. But many questions remain. Why do the craters appear only in specific locations and not uniformly across all thawing permafrost zones? Why are some accompanied by burn marks and others not? Why does the gas buildup reach such violent thresholds in some regions, while in others it dissipates more gradually? And perhaps most curiously, is this really a modern phenomenon, or the return of an ancient cycle we've forgotten? Some scientists and researchers have begun to explore the possibility that the seeds of these craters were planted during the last ice age, or even before. The Yamal Peninsula, where many of these craters have appeared, is rich in relics from the Pleistocene. Mammoth tusks, woolly rhinoceros bones, and remnants of extinct steppe species are frequently unearthed from thawing ground. Could it be that decomposing Ice Age biomass, plants and animals that died tens of thousands of years ago, are now releasing gases in massive, unpredictable bursts? This idea draws an eerie connection between the present and the past, that what we are witnessing today may be the delayed aftershock of ancient extinction events, a final breath from ecosystems long gone. Other researchers look to thermokarst formations, where melting ice lenses in the soil cause sudden ground collapse. Yet these do not explain the explosive nature of the craters, or the visible violence of the ejections. Thermokarst creates sinking, not eruptions. The Siberian craters behave more like blasts, which leads some into more speculative territory. Could the permafrost craters be the visible result of deep geological processes still poorly understood? Methane hydrates, frozen methane trapped in crystalline ice lattices, exist in the deeper layers of permafrost. Under certain thermal and pressure conditions, these hydrates may destabilize explosively. If that's the case, then these craters might be surface expressions of subsurface transitions, where changes set in motion during the Ice Age are only now reaching a critical point. Still others ask whether external factors might be involved. Some point to changes in the Earth's geomagnetic field, solar cycles, or even seismic activity as possible triggers for permafrost destabilization. Could fluctuations in cosmic radiation or shifts in subsurface electrical currents play a role in methane release? Such ideas remain on the fringe, but they reflect a growing acknowledgement that we may not yet fully grasp the complexity of Earth's deep freeze. And while many permafrost craters have now been documented, new ones continue to appear, often in remote areas. Some have even been discovered accidentally by reindeer herders or spotted by satellite long after formation. In some regions, small domes of uplifted ground have been observed, known ominously as gas blowout mounds, pressurized bubbles waiting to burst. How many more of these mounds exist, undetected, and how much gas remains trapped beneath? There is also the strange coincidence of timing. The rise in crater formation parallels a period of accelerated Arctic warming, which itself may be part of a larger climatic pattern stretching back thousands of years. Are we, unknowingly, living in the feedback loop of a warming process that began at the end of the last ice age? And if so, what else might be waiting beneath the thaw? As the permafrost yields its secrets, bones, tools, viruses, gases, it raises deeper questions about what was preserved and what should remain undisturbed. The craters themselves, dark and silent, are not just geological features. They are punctuations in time, breathing wounds in the earth, signals that something below the surface is waking. Whether from human influence, natural cycles, or ancient triggers, the land is shifting in ways we still struggle to comprehend. Each new crater invites a renewed investigation, not only into Siberia's frozen landscape, but into our own understanding of the forces that shape the planet. Is this a warning? A relic? A message in the earth? The ground remains quiet until it doesn't. And as the ice continues to melt, we are left to wonder, what else sleeps beneath the frost? As we leave behind the rupturing frost of Siberia's explosive craters, our journey continues, not south, but across a lost land now drowned beneath the waves. A land once frozen, vast and windswept. A place not quite Asia, not yet the Americas. Beringia, a bridge between worlds, and possibly the cradle of a vanished people whose footsteps were never meant to be erased. Today, the Bering Strait is a narrow, frigid channel separating far eastern Siberia from western Alaska. But during the last ice age, when global sea levels dropped by over 400 feet, the ocean receded to reveal a massive corridor of exposed land, Beringia. At its peak, it stretched nearly 1,000 miles from north to south and over 1,600 miles from east to west. A subcontinent of Ice Age tundra, rich in grasses, steppe animals, and, perhaps, human life. To many, this land bridge has long been seen as a passageway, a temporary corridor that early humans crossed while following herds of mammoth and bison, eventually populating the Americas. But recent evidence suggests a more complex story. Not a bridge, but a homeland. The Beringian standstill theory challenges older assumptions about human migration into the Americas. Rather than a quick crossing from Siberia to Alaska, this theory proposes that a population of humans settled in Beringia and remained there, isolated for thousands of years. Trapped between massive ice sheets to the east and west, they may have lived in ecological isolation during the harshest millennia of the Ice Age. Genetic evidence supports this idea. Modern Native American populations share unique genetic markers that appear to have diverged from their Siberian ancestors between 25,000 and 20,000 BC, long before there was a clear route south into the Americas. But curiously, these same genetic signatures don't show up in archaeological remains south of the ice sheets until much later, around 13,000 BC. So where were they in the meantime? The answer may lie beneath the waves, in a sunken world now hidden beneath the Bering and Chukchi seas. A vast plain of grassland, once home to mammoths, musk oxen, and possibly early humans. Beringia may have offered shelter, food, and stability during one of Earth's most unforgiving eras. Could an entire civilization, or at least a distinct culture, have existed here, out of reach, out of time? Beringia was not a frozen wasteland. Though cold, the region was largely ice-free, thanks to its unique climate. Shielded from the direct impact of continental glaciation, it likely maintained a dry and stable steppe-like environment. Some scientists refer to it as the Mammoth Steppe, a superbiome stretching from Europe to Canada, filled with hardy plants and grazing megafauna. In this Ice Age sanctuary, people may have hunted, built shelters, crafted tools, and lived in small, nomadic groups. Archaeological evidence in both Siberia and Alaska shows Paleolithic technologies, such as microblades and bone tools, that suggest a shared cultural memory, a lineage that may trace back to Beringia itself. But the land is gone now, submerged by rising seas around 11,000 BC, when Earth's climate warmed dramatically. What remains is circumstantial: genetic traces, scattered artifacts, and the absence of direct evidence where we would most expect to find it, underwater. Could lost sites, settlements, camps, even ceremonial structures be lying at the bottom of the Bering Sea? And if so, what stories would they tell? The Beringian standstill theory has inspired further questions, some grounded in science, others teetering on the edge of the unexplained. For example, how isolated was this Ice Age population? Could long-term separation have led to unique adaptations, biological or cultural, that set these people apart. Some speculative anthropologists have drawn comparisons to early myths found among Native American groups. Stories of sky people, land bridges, and spirit animals that seem to echo Ice Age landscapes. Other fringe interpretations suggest that Beringia may have been more than just a survival zone. Could it have been a center of innovation, perhaps even a point of origin for traditions later seen in both the Americas and Northeast Asia? Certain ancient motifs, like the spiral, the thunderbird, or the Great Flood, appear across continents. Coincidence? Or distant echoes from a shared, submerged past? Then there is the unsettling question. Why haven't we found more? Why is there so little direct evidence of sustained human occupation in Beringia? No mammoth bone huts, no elaborate burial sites, no clear artistic expressions like the cave paintings of Europe? Is it simply that such sites now lie underwater, beyond the reach of conventional archaeology? Or is there something else, some disruption, some unknown event that wiped these traces clean before the sea could claim them? Some researchers believe that changing climate alone may not account for Beringia's disappearance. Were there localized catastrophes, earthquakes, floods, or even methane releases, akin to those forming today's Siberian craters? Events powerful enough to erase entire lifeways in a single generation. Today, as sonar mapping and underwater archaeology begin to explore the sunken plains, there is renewed hope that Beringia's secrets may not be lost forever. Sediment cores taken from submerged regions have revealed traces of pollen, plant matter, and ancient DNA, faint whispers from a time when the tundra was dry and teeming with life. New tools may yet uncover hearths, tools, or even the remains of those who called this in-between land home. But until then, the story remains fragmented. We know that humans lived in Beringia. We know they stayed, longer than expected. And we know they eventually moved on, becoming the ancestors of nearly every indigenous group in the Americas. But what happened during that standstill? What did they see, learn, create, and leave behind? In the vast silence of the north, beneath the restless sea, a chapter of human history lies unread. The Beringian standstill is not just a theory. It is a mystery of identity, migration, and the fragile thread that binds past to present. And like the other Ice Age enigmas we've explored, it leaves us with one final question. What else have we forgotten that still waits beneath the ice? From the sunken plains of Beringia and its long-forgotten inhabitants, we now follow the trail southward, deep into the arid heart of what is now New Mexico. A vast expanse of white gypsum dunes stretches across the desert, silent and shimmering under the sun. But hidden beneath this dazzling landscape lies something far older than the sand itself. A mystery pressed into the earth, a story told not in words or stone, but in footprints. In White Sands National Park, where the wind has sculpted waves of powder-fine dunes for millennia, researchers made a startling discovery. Fossilized human footprints, dozens of them, extending across an ancient lakebed now long dry. Some are faint, others crisp and clear. They show adults walking steadily, sometimes with burdens on their backs. They show children running, stumbling, being lifted. There are animal prints too, mammoths, giant ground sloths, dire wolves, overlapping, intersecting, frozen in time. At first glance, the scene appears ordinary. People walking, going somewhere, perhaps returning. But the soil tells a different story. Radiocarbon dating of seeds trapped in the footprints' sediment layers has yielded astonishing results. Some of these prints date to 23,000 BC, thousands of years earlier than previously believed human presence in the Americas. If these dates hold, They shift the timeline of human history on this continent dramatically and open the door to a deeper mystery. For decades, the prevailing model of human migration into the Americas held that the first peoples arrived from Siberia through Beringia, crossing a land bridge during the last glacial maximum and entering through an ice-free corridor sometime around 13,000 BC. These early arrivals were thought to be the ancestors of the Clovis culture, long held as the first well-documented society in the Americas. But the footprints at White Sands predate Clovis by nearly 10,000 years. If people were already in the American Southwest by 23,000 BC, then how did they get here? Did they arrive before the ice sheets closed the land bridge? Before the corridor into the continent even existed? Or did they come by another route entirely? Some researchers suggest the coastal migration theory, that early humans followed the Pacific coastline by boat, skirting glaciers and living off marine resources. This kelp highway would have been a viable path, but it's also mostly underwater today, and hard evidence remains scarce. Others suggest a deeper, older migration, perhaps tens of thousands of years before even the White Sands prints. Could multiple waves of early peoples have reached the Americas by sea, island hopping across the Pacific, or even from the Atlantic? Could these earliest settlers have vanished, leaving only ephemeral traces behind? The footprints speak, but only faintly. Beyond their age, it's the humanity of the tracks that captivates. Some footprints are small, made by children, likely under the age of 3. Others belong to adolescents or young adults, who seem to carry younger companions in repeated patterns. One sequence shows a person walking with a toddler in their arms, slipping slightly under the added weight. On the return journey, the footprints suggest the child walked independently. A snapshot of a moment, a gesture, a decision, captured in mud and preserved for over 20,000 years. Nearby, sloth prints show evidence of avoidance behavior, circling, changing direction, as if the animals saw or sensed the humans and altered their paths. In some places, sloths appear to rear up on 2 legs, claw marks gouging the mud, perhaps in defense or curiosity. This is not abstract history. This is lived experience, etched into the earth with startling immediacy. But it also raises questions. Where did these people come from? Where did they go? Why have we found so few other traces of their existence? No bones, no campsites, no tools within the same strata. Was this a fleeting visit, a seasonal passage, or evidence of a much broader settlement that remains hidden? Some scholars argue that the dating of the footprints might be flawed, that aquatic plant seeds used for radiocarbon dating can yield inaccurate results, especially in ancient lake beds. Could younger material have leached into older sediment layers, giving a false age? Or might contamination have introduced discrepancies? Yet multiple dates from different tracks and locations reinforce the same window of time, suggesting the evidence is robust. Still, debate continues, as it often does with discoveries that challenge long-held paradigms. Others, on the speculative fringe, see in the White Sands prints the echoes of a lost chapter of human migration, perhaps tied to the hypothesized Beringian population, or even to cultures now erased from both the record and memory. Could there have been an earlier wave of migration, now vanished beneath sediments, seas, and shifting ice? Or a civilization that moved like a whisper across the continent, present but unpreserved? Some indigenous oral traditions speak of ancient peoples walking the land long before the known ancestors arrived. Stories of migrations, floods, and vanished worlds that predate the current order of things. Might these footprints be a physical echo of those stories? Today, the ancient lake bed of White Sands is dry and still. The footprints remain, fragile yet stubborn, uncovered by erosion, wind, and careful excavation. Scientists work meticulously to preserve them, knowing that time and weather will one day take their toll. But for now, they remain, a trail across deep time. These are not fossil bones or tools left behind. They are impressions made in motion, choices frozen in earth. A moment when someone walked across a muddy lake shore in a world of mammoths and sloths, and left a mark that would outlast all memory. How many more such footprints lie hidden beneath deserts, grasslands, and ancient floodplains? And if these people lived and moved in the Americas during the Ice Age, what else did they leave behind, waiting to be uncovered? In the ghostly silence of white sands, the past walks beside us, quietly, step by step, and the earth remembers. From the wind-etched footprints at white sands, we follow the trail further, not across land, but beneath the sea. Here, in the world's shallow coastlines, lie secrets untouched by human eyes for millennia. Forgotten shorelines, lost rivers, and perhaps entire settlements swallowed by the rising tides of a warming earth. They are out of reach, but not out of mind. The ocean floor hides more than coral and shipwrecks. In places like the Dogger Bank beneath the North Sea, off the coasts of Palestine and Lebanon, and along the once dry plains of the Sunda Shelf in Southeast Asia, evidence is slowly emerging of a world drowned after the last glacial period. These were not merely floodplains or marshy lowlands. They were once home to thriving Ice Age landscapes, lush with life, roamed by game, and, as many researchers now suspect, inhabited by early humans. Roughly between 20,000 and 8,000 BC, as the great ice sheets began to melt, global sea levels rose by more than 400 feet. Entire continents shifted shape. Coastal settlements, if they existed, would have been among the first to vanish, claimed not by violence or decay, but by the quiet, relentless advance of the sea. But did such settlements really exist? If so, where are they now? Clues have begun to surface, sometimes literally. In the North Sea, trawl fishermen have recovered worked flint tools, bone harpoons, and even the remains of mammoth and reindeer, all pulled from the seabed miles from modern shorelines. These artifacts point to a lost landmass now called Doggerland, a vast, once habitable region that connected Britain to mainland Europe. Archaeologists believe it may have been a rich habitat, dotted with lakes, rivers, and grassy plains, a place where humans hunted, gathered, and possibly even settled. Sonar mapping of the seafloor has revealed ancient river valleys and lake beds, now buried in sediment. Could villages have once lined these banks? Could there be hearths, dwellings, or ceremonial sites sealed beneath layers of silt? If so, they remain largely untouched, hidden beneath water, mud, and time. Similar finds have been made off the coast of India, near the Gulf of Khambhat. In 2001, an underwater survey revealed a grid-like pattern of stone structures at a depth of over 120 feet. Sonar scans suggested the presence of walls, basins, and possible artifacts. Some interpreted these findings as evidence of a submerged urban center, perhaps older than any known civilization. But the site remains controversial. The current is strong, visibility is poor, and excavation is nearly impossible. While some see tantalizing hints of a lost settlement, others caution that natural geology can mimic human architecture. The mystery remains unresolved. What makes submerged settlements so elusive is not only their location, but their implications. If sophisticated communities existed along Ice Age coastlines, they would have been wiped clean by the post-glacial sea level rise. Erosion, sedimentation, and time would erase all but the most durable traces. And yet, the logic is inescapable. As humans spread and adapted, Coastlines would have offered ideal habitats, mild climates, abundant food, access to rivers and trade. Why would people not have lived there? Today, nearly 40% of the world's population lives near the coast. The same may have been true for our ancestors, which means that many of their oldest settlements may now lie beneath the sea, out of sight, but not necessarily out of reach. Off the coast of Japan, at Yonaguni, divers discovered a series of stepped stone structures beneath the water. The formations appear too geometrically precise to be random: staircases, terraces, and flat platforms. Some claim it's a natural formation sculpted by tectonics and erosion. Others suggest it may be a ceremonial platform built during the last ice age, long before the rise of Japan's earliest known cultures. Again, the evidence is ambiguous, but the possibility lingers. Could these underwater sites be the missing links between Ice Age hunter-gatherers and the first agricultural civilizations? Could they represent cultural traditions, spiritual practices, or early architecture now lost to time? Fringe theories stretch even further. Some speculate that ancient legends of sunken worlds, from Atlantis to Lemuria, may be dim cultural memories of real places lost during the rapid sea level rise. While these tales are often dismissed as myth, they reflect a common theme found across continents: floods, drowned lands, gods angered, knowledge lost. Are these merely metaphors for seasonal monsoons and shifting rivers? Or could they reflect deep-time oral histories, passed down for generations, encoding events of global transformation? Even some mainstream archaeologists now acknowledge that underwater archaeology is still in its infancy. The technology to explore deep and turbid coastal waters is only now becoming widely available. As sonar improves and robotic submersibles extend our reach, new discoveries may emerge: settlements, graves, tools, even art, preserved in anaerobic conditions, waiting beneath the silt. In the eastern Mediterranean, submerged Neolithic structures have been found off the coasts of Palestine and Cyprus: stone walls, circular buildings, and megalithic features dating to around 6000 BC. What else lies farther out, beyond the continental shelf? What was lost when the oceans rose? The search continues, slowly, methodically, but always with the same sense of wonder and the same tantalizing question. If humanity's story began in the highlands and hills, why do so many echoes of civilization point toward the sea? Could it be that the first cities, the first temples, even the first languages were born in lands we can no longer see? That the foundations of culture, long assumed to rise with the rivers, may in fact lie submerged beneath forgotten coastlines? And if so, how much of our history remains undiscovered, sheltered beneath waves that have lapped silently for 10,000 years? The water hides, but the earth remembers, and somewhere below, something ancient waits. From the drowned coastlines of lost Ice Age settlements, we now return to dry land, at least to what land would have been. The windswept shores of Ice Age Europe, where stone flints once shaped survival and mystery clings to the cold breath of the Atlantic. In this next chapter, we follow an idea that challenges everything we thought we knew about the peopling of the Americas. A theory born not in the New World, but on the ancient edges of the Old. In southwestern France and northern Spain, archaeologists have long studied a remarkable Ice Age culture known as the Solutrean. Active between 22,000 and 17,000 BC, the Solutrean people left behind finely crafted stone tools, leaf-shaped blades, laurel points, and intricate bifaces unlike anything else in Europe at the time. These tools suggest a high degree of skill, even artistry. What sets the Solutreans apart is their precision. Their flint-knapping techniques reveal a level of refinement rare in Paleolithic contexts. Thin, symmetrical blades flaked from both sides, optimized not just for utility, but for control and consistency. It's no surprise that some archaeologists consider them one of the most technologically sophisticated Ice Age cultures in Europe. But the real mystery begins not with what the Solutreans made, but where similar tools appear again, across an ocean, in a land no one thought they had reached. In the early 20th century, discoveries in North America began to stir debate. Near Clovis, New Mexico, and in other sites across the United States, archaeologists uncovered the now famous Clovis points, broad, fluted spearheads dated to around 13,000 BC. These tools were once believed to mark the earliest human presence in the Americas. But to some researchers, the Clovis points bore an uncanny resemblance to the Solutrean blades of Ice Age Europe. Could there be a connection? This possibility led to the birth of the Solutrean hypothesis, a controversial theory proposing that people from Ice Age Europe may have reached North America by boat, navigating the icy edge of the Atlantic via floating sea ice, thousands of years before the Beringian land bridge became passable. It's a bold claim, one that rewrites timelines, challenges migration models, and introduces transatlantic contact millennia earlier than anyone had imagined. Is it even possible? The Ice Age. Atlantic was not the vast, impassable expanse we imagine today. During the glacial maximum, with sea levels significantly lower and ice sheets extending far south, the distance between Western Europe and Eastern North America may have been shorter, not by miles, but by accessibility. Some proponents argue that an ice bridge, not of solid land, but of pack ice, seals, driftwood, and sheltering floes, may have created a navigable route. Similar to how the Inuit later hunted along the ice edge in the Arctic, the Solutreans, adapted to cold climate life, might have slowly migrated west, following seasonal game and using simple watercraft or rafts. Supporters of the theory point to several key arguments. The tool similarities between Solutrean and Clovis technologies, though debated, show striking parallels in manufacturing technique and form. A handful of prehistoric artifacts found on the eastern seaboard of the United States appear to predate Clovis and do not fit neatly into known Beringian-derived cultures. The absence of Clovis precursors in northeastern Siberia or Alaska raises the possibility that at least part of the Clovis technological package may have originated elsewhere. Furthermore, in 1970, a controversial find known as the Sinmar biface emerged from the Atlantic seabed near the Chesapeake Bay. Dredged up by a scallop boat, it was reportedly found in association with mastodon remains, and both were dated to around 20,000 BC, within the Solutrean timeframe. If true, it would place a Solutrean-style tool in North America thousands of years before Clovis. But the find remains contentious. Its provenance is disputed. The site is inaccessible. And without context, the object can't prove transoceanic contact. Mainstream archaeology remains skeptical of the Solutrean hypothesis. Most scholars argue that the similarities between Solutrean and Clovis tools are superficial, that different cultures often develop similar technologies independently, especially when facing similar environments and challenges. They point out that Solutrean points, though refined, do not feature the distinctive flute channels seen in Clovis tools. Critics also challenge the logistical feasibility of such a migration. Were Ice Age Europeans truly capable of navigating the North Atlantic? Is there any evidence of maritime tradition among Solutrean peoples? And why are there no clear intermediary sites along the supposed migration route? No campsites, no middens, no stepping stones. Still, the theory persists, fueled by mystery and the occasional find that doesn't quite fit the accepted models. Beyond the debate lies a deeper intrigue, the tantalizing possibility that human history is far more complex than we assume. The Solutrean hypothesis, whether right or wrong, invites us to ask larger questions. How many early migrations have left no trace? How much of our ancestry lies in stories not told by bones and stones, but by the silence between them? Could there have been contacts across oceans during the Ice Age? Not in fleets or empires, but in small, scattered journeys, now almost entirely erased? And if one group of humans found their way across the Atlantic during a time of ice and darkness, what other journeys might have been made, now lost beneath sea and sand? Today, the icy path that may have once connected Europe to America has long since melted. The Solutreans themselves vanished from the archaeological record over 17,000 years ago. Their descendants, if any, are unknown. Their words are lost. Their boats, if they had them, have rotted to nothing. But perhaps, somewhere beneath the Atlantic silt, or in the deeper layers of America's eastern soils, more clues remain. Waiting for the right question, the right eye, the right moment to resurface. And when they do, we may find that the story of how humans reached the Americas is not just one of land bridges and corridors, but of oceans crossed and horizons pursued. Even when the world was ice, from the uncertain crossings of Ice Age oceans, we now turn inward, deep into the ground itself, into a place where time doesn't erode but holds tight, where the bones of an ancient world still lie tangled in black pitch, perfectly preserved, unnervingly abundant. Just off a boulevard in modern-day Los Angeles, traffic roars past. But here, beneath the city's surface, the Ice Age has not ended. The Brea Tar Pits, a name that conjures images of black ooze, bubbling pits, and creatures struggling in their final moments, are more than a geological oddity. They are a portal, a rare, almost supernatural place where the fossil record appears not in fragments, but in overwhelming abundance. And unlike many fossil beds scattered sparsely across the globe, La Brea is dense. Strangely dense. Within a few square miles, paleontologists have uncovered more than 3.5 million fossils, representing over 600 species of animals and plants. From microscopic pollen to towering mammoths, from saber-toothed cats to dire wolves, each layer tells of life and death, preserved in thick, viscous asphalt, seeped up from the Earth's crust over tens of thousands of years. But beyond the sheer volume of life recovered here, a deeper mystery lingers. Why so many? Why here? And why such a disproportionate number of predators? The standard scientific explanation begins with natural asphalt seeps, areas where petroleum from deep underground migrates upward through faults, pooling at the surface. In Los Angeles, this process has been active for at least 50,000 years. As surface water gathered in shallow depressions atop the tar, animals mistook the dark, sticky patches for drinkable ponds or safe crossing points. A large herbivore, such as a mammoth or bison, would wander in, become trapped in the sticky substance, and struggle helplessly. Their cries would attract predators, wolves, big cats, vultures, who in turn would become ensnared, creating a grisly chain of entrapment. Over time, layer after layer of this biological tragedy built up, each entombed in slow-moving petroleum, protected from oxygen, decay, and the ravages of time. It's a compelling narrative, clean, logical, and yet the numbers don't quite add up. At La Brea, for every herbivore found, there are an estimated 9 predators. This inverse of the natural food chain is startling. In most ecosystems, prey animals outnumber predators by a wide margin. It's a basic law of population dynamics. More grazers, fewer hunters. So why is the record here inverted? One theory holds that entrapment bias is at work, that the moans and thrashing of a trapped animal might have lured multiple predators at once, causing mass entrapment events. Imagine a bison stuck in the tar, its death cries carrying across the plains. A saber-toothed cat approaches, then another, then a wolf pack. Each time the tar claims another. But even so, 9-to-1? Some researchers suggest that carnivore social behavior may explain the imbalance. Perhaps Ice Age predators like dire wolves or Smilodon fatalis hunted in groups, and group behavior led to mass entrapment. Or perhaps the herbivores, having adapted better to the dangers of the landscape, were more cautious, more observant, less likely to fall victim. Still, other fossil beds across the world, some with tar-like traps, do not show such dramatic predator skew. So why does La Brea stand apart? There are stranger elements too. Fossils at La Brea are often unusually well preserved, with bones retaining microscopic detail, sometimes even the soft tissues of skin, hair, or collagen. This preservation is thanks to the anaerobic conditions within the tar: low oxygen, low bacteria, high viscosity. But it also means La Brea gives us a clearer window into Ice Age biology than almost any other site on Earth. We've found entire skeletons of saber-tooths, jaws still curled in their final bite. Bird wings outstretched mid-flight, arrested mid-movement. The scattered remains of hundreds of dire wolves, many showing similar injuries: broken ankles, dislocated joints, signs of a shared fate. And then there are the human remains. Only one confirmed Ice Age human skeleton has ever been recovered from the tar pits: the La Brea woman, dating to roughly 9000 BC. Her remains were found alongside a domestic dog and red ochre pigment, possibly suggesting ritual significance. But debate still surrounds her origin. Some believe she may not have been naturally trapped, but buried, perhaps a ceremonial interment within an already sacred or dangerous place. Could early peoples have recognized the tar pits not just as traps, but as gateways? A place where the land devoured life, a realm of both utility and taboo. The fossil record here also hints at sudden ecological shifts. Around 10,000 BC, just as the Ice Age drew to a close, the number and diversity of megafauna fossils at La Brea sharply decline. Mammoths vanish, horses and camels disappear. Saber-tooths and dire wolves follow shortly after. Only smaller species, more adaptable, remain. It's a familiar pattern. We've seen it in the megafaunal die-off discussed earlier. But could La Brea hold more precise clues to what caused that extinction? With its extraordinary density, it offers a nearly continuous record of changing fauna, flora, and climate. Pollen trapped alongside bones paints a picture of shifting ecosystems, from glacial tundra to post-glacial woodlands, and tar samples reveal changes in atmospheric carbon, hinting at global warming long before human industry. Still, the trigger remains unclear. Climate change? Overhunting? Disease? Or some combination? Or something else entirely? Some fringe thinkers have even speculated that La Brea might record the aftermath of catastrophe, a comet airburst, as proposed in the Younger Dryas impact hypothesis. A sudden climatic shock could have destabilized ecosystems, pushing stressed animals toward known watering holes, like La Brea. In this view, the site becomes not just a trap, but a mass grave from a time of collapse. Others point to the anomalous fossil density itself as evidence that Los Angeles during the Ice Age may have been a unique convergence zone, where climate, migration corridors, and geological factors created an intense concentration of life. A crossroads, or perhaps a bottleneck. Today, the tar still bubbles in slow motion. The museum displays jawbones and skulls, tooth marks etched by time. But beneath the glass and concrete lies a world still largely unexcavated. Countless fossils remain in situ, sealed in pits awaiting future researchers and future questions. Because even here, surrounded by urban sprawl and concrete, the past is not finished speaking. Why so many predators? Why here? What happened to tip this balance and freeze it forever in oil and bone? The answers, if they exist, remain just beneath the surface, thick, dark, and waiting. From the dense fossil archives of the Brea Tar Pits, where time clings like tar to the bones of the vanished, we journey now into the stark, frozen expanses of the far north. A land seemingly untouched by time, but buried beneath the Siberian permafrost are remains that tell a story both intimate and immense. Not fragments of bone, nor impressions in stone, but whole bodies. Mammoths frozen mid-step, their eyes intact, their last meals still in their mouths, as if in some unimaginable moment, time simply stopped. In the icy reaches of Yakutia, in northeastern Siberia, the Earth has long preserved the bones of Ice Age megafauna. But beginning in the 18th century and continuing into the modern era, something more extraordinary began to emerge. Mummified mammoths, entombed in ice, remarkably preserved, hair, skin, organs, and most mysteriously of all, undigested food in their stomachs. Some specimens appear so fresh that early reports described the meat as edible. In one famous case, the Berezovka mammoth, discovered in 1901, researchers noted green grasses and buttercups lodged in the animal's mouth, torn mid-chew. Stomach contents included flowers, mosses, and sedges, plants from a warmer seasonal tundra. Yet this animal now lay in permanent frost, frozen so quickly that its last bite never reached the stomach for digestion. What kind of force could cause such instantaneous death and deep freezing? And what does this mean for our understanding of the Ice Age world? Mainstream science offers several interpretations. The mammoths likely died during warmer seasons, late spring or summer, when vegetation was plentiful. A sudden drop in temperature, perhaps linked to Arctic storms or mudslides, may have buried them in sediment that later froze solid, preserving their bodies. But here's where the mystery deepens. To preserve organic matter in this state, decay must be halted almost immediately. Soft tissue, even under cool conditions, begins to break down within hours. Bacterial activity sets in quickly. For muscle, organs, and even the contents of a digestive tract to remain intact, the temperature would have needed to drop well below freezing, perhaps to 40 degrees Celsius or colder, within a matter of hours or even minutes. And not just once. This phenomenon has occurred repeatedly, across a wide swath of the Siberian Arctic, and even into Alaska and northern Canada. Could such rapid freezing have happened naturally? And if so, what atmospheric or cosmic forces could trigger such events? Some scientists have proposed sudden local collapses of terrain, where mammoths grazing near thawing riverbanks might have fallen into mudslides, or even been swept into icy waters and buried under debris, preserved by the cold environment that followed. Others point to climatic anomalies, such as massive blizzards, capable of dropping temperatures with lethal speed. But even the most severe blizzards we know of fail to freeze something as large as a mammoth to its core without significant decomposition. And still the question remains, why do we find undigested food in so many of these animals? Flash freezing is a concept largely foreign to natural Earth processes. In the lab, it requires controlled environments, supercooled surfaces, or cryogenic conditions. In the wild, it seems improbable, unless a force acted on a scale we don't fully understand. This has led to more speculative ideas, some grounded in science, others straying toward the fringe. One proposal ties the phenomenon to the Younger Dryas impact hypothesis. If a comet or asteroid exploded over the Laurentide ice sheet or elsewhere in the northern hemisphere around 12,800 years ago, as some evidence suggests, the impact could have triggered shock waves, firestorms, and sudden atmospheric upheaval. Such an event might create temperature inversion layers, drawing frigid air from the stratosphere downward at astonishing speed. Could such a rapid cooling, even if brief, have created localized cryogenic conditions, enough to freeze animals in the act of grazing? Some models even suggest that blast winds from an atmospheric detonation could drop temperatures dramatically within minutes. This would align with some of the physical trauma seen in mammoth remains: broken bones, internal hemorrhaging, and collapsed organs, all without signs of prolonged struggle. Others have theorized more esoteric explanations. Could shifts in Earth's axis or polar reversals have caused abrupt climate swings? Could methane releases from deep permafrost have suffocated animals en masse before sudden burial under frost? Or did a cosmic event, a solar outburst, or gamma radiation burst, trigger a rapid cascade of atmospheric changes? Some fringe thinkers go further, suggesting ancient cataclysms, global floods, or lost technological interventions. But these remain speculative shadows, unsupported by hard evidence. What remains indisputable, however, is the biological clarity of the mammoth remains. In the best preserved cases, we can extract DNA, examine their diets, and even understand their diseases. We know they lived in herds, that they grazed on grasses, herbs, and seasonal flora, that they bore stress markers from changing climates, and that some of them died abruptly during seasons when the world around them was still green. The mystery isn't just in the preservation, it's in the story told by their bodies, a story frozen mid-sentence. In one instance, a young mammoth calf was discovered with milk residue in its stomach and signs of an active immune system at the moment of death. Another bore a crushed skull, suggesting an external trauma. But no predators nearby, and no signs of decay. These are not scattered bones unearthed in dry riverbeds. These are moments preserved by something more than sediment, held in place by cold and time, and some force still poorly understood. And as the permafrost thaws, accelerated by modern climate change, more of these frozen giants are emerging. Some nearly complete, some with visible wounds, all of them messengers from a world that ended too fast, and perhaps too strangely. What killed the mammoths? Climate? Hunger? Humans? A celestial event? Or something we've yet to name? The frozen dead of Siberia may hold the answers, or they may only deepen the mystery. Because every new find offers not just more evidence, but more questions. What kind of world did they die in? And what kind of world, ours, did they leave behind? The mammoth's last breath may yet speak, but only if we listen carefully through the ice. From the frozen tombs of flash-preserved mammoths, we shift our gaze to a vast inland sea that once sprawled across the heart of North America. Today, there is little trace of its magnitude, just ridged plains, scattered lakes, and ancient shorelines etched into the landscape. But once, it was the largest body of fresh water on Earth, and when it drained, it may have altered the course of history itself. Where Minnesota now meets Manitoba and Saskatchewan, where wheat fields ripple in summer winds and northern forests stretch toward the Arctic, the remnants of Lake Agassiz lie hidden beneath the soil. A ghost of water that, at its peak, held more than 440,000 cubic kilometers of fresh water, larger than all of today's Great Lakes combined. Formed at the end of the last ice age, Lake Agassiz existed between roughly 12,000 and 8,000 BC, trapped between the retreating Laurentide ice sheet and the rising land left in its wake. As glaciers melted, torrents of water accumulated, dammed by ice and moraine. For thousands of years, the lake expanded, reformed, and shifted, sometimes flowing south into the Mississippi, at other times northeast or northwest, depending on the ice barrier's hold. But then, something changed. Suddenly, violently. Lake Agassiz drained. The story of Lake Agassiz's draining is one of geologic scale and deep time, but also of sudden transformation. At least twice, and perhaps more, the lake experienced catastrophic releases of water, spilling into the North Atlantic with astonishing force. One of the most significant outbursts is believed to have occurred around 8,200 BC, known as the 8.2 kilo-year event. This release may have been responsible for a sharp, global drop in temperatures that lasted for over a century. The freshwater influx is thought to have disrupted the Atlantic meridional overturning circulation, a crucial component of Earth's climate engine. Ocean currents slowed, weather patterns shifted, glaciers surged. Across Europe, Africa, and the Middle East, rainfall declined, rivers dried, and temperatures dropped. In parts of North America and northern Eurasia, colder, drier conditions gripped entire regions. Crop failures, shifting animal herds, and long-term ecological stress would follow. But how could one lake cause so much disruption? To understand the magnitude of this event, imagine a body of water the size of the Black Sea, perched above sea level, suddenly released. As ice dams fractured, perhaps under their own weight, perhaps triggered by seismic activity or warming pulses, billions of gallons of water rushed toward the sea in a matter of weeks or even days. Evidence of this flood is etched across Canada and the northern United States. Giant spillways, scoured bedrock, ancient river deltas, and gravel ridges tracing a flow path to Hudson Bay, St. Lawrence River, and even possibly Mackenzie Basin. Some researchers believe the final outburst sent a massive plume of fresh water directly into the North Atlantic, rapidly reducing ocean salinity and interrupting the conveyor belt of warm water that keeps the Northern Hemisphere temperate. Was this a single event, or a series of pulses? Sediment cores from the North Atlantic show distinct layers of freshwater deposition. Greenland ice cores reveal sudden cooling, an unmistakable climatic fingerprint. In Europe and Western Asia, archaeological evidence suggests human populations reorganized, migrated, or collapsed during this period. Could the draining of Lake Agassiz have reshaped early civilization? Could it have sparked floods remembered in myths, or driven migrations that set the stage for agriculture and urban life? Speculative theories have taken root here, at the intersection of known geology and human memory. Some researchers have linked the 8.2 kilo-year event to ancient flood myths, the Sumerian epic of Gilgamesh, the biblical flood of Palestine and Mesopotamia, Greek tales of Deucalion, stories from India, China, and the Americas all speak of sudden, overwhelming waters. Could these stories be distant cultural echoes of real cataclysms? Events passed down orally, then mythologized as morality tales? Others question the timing. If Lake Agassiz's outflow did coincide with these stories, might it suggest a global awareness of environmental trauma? A shared memory of climate chaos on a scale that defies coincidence? More fringe interpretations see the lake's draining not as a natural process, but as part of a larger pattern of sudden planetary changes. Could it have been triggered by a celestial impact, similar to the proposed Younger Dryas event? Some researchers have suggested that meltwater pulses, like those from Lake Agassiz, may align suspiciously with known impact markers and temperature anomalies. Others speculate about crustal displacement, pole shifts, or even unknown geological forces that could explain the rapid flooding. But such theories remain largely unsupported. The Earth is complex enough without invoking lost planets or secret forces. Still, the scale of Lake Agassiz defies easy explanation. Modern climate scientists now study the lake's history with renewed interest, not just for what it tells us about the past, but for what it might warn us about the future. With Greenland's ice sheet melting and the Arctic warming, the Atlantic's current system, the same one Agassiz once disrupted, is again showing signs of weakening. Could another infusion of fresh water trigger a new cooling event? Or worse, a permanent shift in climate systems? And what if the lake didn't just drain once? Some researchers propose that Lake Agassiz may have filled and emptied multiple times, each outburst shaping not just landscapes, but the trajectory of human life. Each flood potentially altering migration routes, cultural developments, even the emergence of legends and spiritual beliefs rooted in survival. What else lies buried beneath those ancient lake beds? We find stone tools, fossilized wood, peat layers preserving a story in silence. But if humans were there, watching, fleeing, or rebuilding, we have yet to fully understand their role in the story. Were they witnesses to the flood or its survivors? Lake Agassiz no longer exists. Its waters have long since merged with oceans, but its absence still shapes the land and the climate millennia later. And its mystery, like the vanished mammoths or the black mat layer, remains imprinted on the earth. What began as a hidden inland sea ended as a force that may have chilled the world. And yet, we still don't fully know how it drained, why it drained when it did, or if we've even uncovered the full extent of its influence. Somewhere in the deep layers of ice cores, ocean floors, and forgotten sediments, the answers may lie, waiting like the water once did, still and powerful, until everything changed. From the quiet ripple of Lake Agassiz's vanished waters, we move now into the deeper violence of Ice Age hydrology, toward forces not simply vast, but cataclysmic. This is the story of floods so immense they carved out canyons in days, moved mountains in moments, and reshaped the earth in ways still visible from space. Their scars stretch across continents, and yet their cause remains only partially understood. These are the glacial megafloods, the forgotten titans of water and ice. In the dry steppe of eastern Washington state, there is a place that defies conventional geography. Towering basalt columns stand like broken pillars. Canyons, or coulees, slice through the land, their scale out of proportion with the gentle rivers that now flow at their feet. Massive boulders, some weighing thousands of tons, lie scattered miles from their origin, as if dropped by an unseen hand. This is the channeled scablands, one of the most dramatic landscapes left behind by a glacial megaflood. For decades, geologists puzzled over the region's jagged features. Early theories attributed them to slow erosion, gradual processes acting over millions of years. But in the 1920s, a geologist named J. Harlan Bretz proposed a radical idea that the scablands were formed not over eons, but in a matter of days or weeks, by an unimaginably massive flood. His theory was met with ridicule. At the time, such cataclysms were considered unscientific, too biblical, too mythic. But as evidence mounted, Bretz was vindicated. The scablands were, indeed, carved by a catastrophic event, one that released the waters of glacial Lake Missoula with a force 60 times greater than the flow of all the rivers on Earth combined. But Missoula was just one lake, and the scablands just one chapter. What if this wasn't an isolated incident? What if the Ice Age was punctuated by multiple such floods, happening not just in North America, but across the world? Glacial megafloods are now recognized as a global phenomenon, occurring wherever ice sheets and meltwater met in unstable balance. In Siberia, the Altai mountains hold clues to massive outflows that rival those of Missoula. In Palestine, sediment layers suggest sudden, large-scale flooding events in ancient valleys. In the English Channel, sonar has revealed deep gouges and spillways, hinting at a megaflood that may have carved the divide between Britain and Europe around 150,000 BC. What causes these sudden floods? The leading explanation is glacial dam failure. During the Ice Age, vast quantities of water accumulated in lakes held back by glacial walls. These ice dams could span hundreds of miles, reaching heights of several hundred feet. When they failed, due to warming, internal pressure, or seismic activity, The result was a wall of water cascading across the landscape at speeds exceeding 60 miles per hour. These floods didn't just erode, they obliterated. In the case of glacial Lake Missoula, for example, it's estimated that 500 cubic miles of water were released in a matter of days. The torrent plucked boulders from bedrock, scoured canyons hundreds of feet deep, and left behind ripple marks so large they can be seen from the air, each one taller than a house. And these events may have happened repeatedly. Evidence shows that Lake Missoula filled and drained at least dozens of times during the last glaciation. But here's where the mystery deepens. Some researchers have begun to question whether traditional glacial mechanics can fully explain the speed, scale, and frequency of these floods. If these were truly recurring events, why were the ice dams so unstable? Could other mechanisms be at play? One hypothesis suggests the existence of subglacial lakes and pressurized meltwater chambers, trapped beneath miles of ice. Over time, these pockets could have built up enormous pressure until a sudden shift, an earthquake, or even the collapse of internal ice caverns triggered explosive release. In this model, the flood doesn't begin from above the glacier, but from within it, a hidden reservoir bursting forth with no warning. These jökulhlaups, as they are called in Iceland, have been observed on a smaller scale in modern times, particularly during volcanic eruptions beneath glaciers. But could similar events have occurred during the Pleistocene, on a continental scale? Others look skyward. Could sudden climatic pulses, perhaps from solar activity or post-impact warming, have accelerated melt across vast regions, overwhelming drainage systems and pushing glaciers past a tipping point? There are even theories, though highly debated, that suggest celestial impacts, such as comet fragments or asteroid airbursts, may have destabilized glacial environments in rapid succession. A cosmic trigger, perhaps, for a global flood event. What is clear is that glacial megafloods were not just natural disasters. They were transformative forces, erasing and remaking landscapes in ways we are only beginning to map. In Montana, boulder fields called glacial erratics lie scattered in patterns that trace ancient flood paths. In Canada, inverted valleys show where sediment from rushing water filled in low spots, leaving behind ghostly outlines. In Europe, once dry basins suddenly became lakes or estuaries. Some researchers believe these floods may have created, not just altered, major geographic features. The Columbia River Gorge, the English Channel, the Baltic Sea Basin. Could the same be true elsewhere? And more intriguingly, could ancient humans have witnessed these floods? Here the line between science and story blurs. Indigenous oral traditions in North America speak of rivers that rose like mountains, of water that chased the buffalo uphill. In regions of Europe, Africa, and Asia, flood myths appear again and again, some eerily specific in their language, describing land bridges collapsing, forests drowned, and sky-darkening rains. Are these myths metaphorical or historical? Could small bands of Ice Age humans watching from ridgelines, clinging to high ground, have survived these floods, passing down their memory across generations? And if so, how much else might they have seen, witnessed in silence, preserved in story? The study of glacial megafloods is far from complete. New discoveries are still being made, new sediment layers mapped, new underwater canyons charted. But each find brings the same core realization. That water, in the hands of ice and gravity, is not simply a sculptor of time. It is a destroyer, a rewriter of histories. And just as the earth once held these waters at bay, it also let them go. Why did some floods occur when they did, and not before? What hidden pressures built behind walls of ice, only to explode into the world we now inhabit? The answers may lie deep beneath our feet, buried in old channels, forgotten valleys, or still sealed pockets of ancient glacial flow, waiting for another question, another chance to be seen. When the ice cracked, the world changed. But what exactly did it leave behind? From the thunderous torrents of glacial megafloods, we step now into a quieter landscape, one shaped not by water or fire, but by the creeping shadows of ancient predators. Among rolling green hills and limestone caves in modern-day Britain, fossils whisper of a world few imagine. A world not just of mammoths and woolly rhinos, but of hyenas. Not the scavengers we know from today's savannas, but powerful, bone-crushing hunters that once stalked the northern edges of Ice Age Europe. It's hard to picture now. The misty moors and grassy downs of Britain seem far removed from the arid grasslands of Africa. But beneath the soil, beneath cathedrals, farms, and meadows, lie remains that suggest an entirely different past. During multiple interglacial periods, particularly between 250,000 and 30,000 BC, Britain was home to spotted hyenas, animals genetically and morphologically identical to those still found in Africa today. Their bones have been unearthed from Kent to Yorkshire, most notably in sites like Kent's Cavern, Cresswell Crags, and Devensian River deposits, and not just scattered fragments, but entire skeletons, dens, caches of bones, even piles of gnawed human remains. Who were these predators? How did they survive such extreme climates? And why did they vanish so completely? The spotted hyena, Crocuta crocuta, is a remarkable survivor. Highly intelligent, social, and ferociously adaptive, hyenas today are often mischaracterized as scavengers. But their ancestors in Ice Age Britain appear to have been formidable hunters, capable of preying on horses, deer, and possibly even young mammoths. Their powerful jaws could pulverize bone, leaving behind unmistakable signs: crushed marrow, tooth-scraped cavities, and neatly sorted piles of skeletal debris. In limestone caves across southern and central England, paleontologists have uncovered these telltale signs. In some sites, bones of multiple species are broken in patterns that suggest systematic feeding and caching, not mere accident. In others, fossilized dung, called coprolites, reveals diets rich in meat and bone. One cave in Derbyshire, long believed to be a Neanderthal site, was later identified as a hyena den. Its chambers littered with shattered bones, gnawed skulls, and cub-sized footprints preserved in ancient mud. This wasn't opportunistic scavenging. This was home. But how did such creatures thrive in Britain? The prevailing image of the Ice Age, snowfields, glaciers, and unbroken cold, fails to capture the complexity of its climate. The Pleistocene was not one long freeze, but a series of glacial and interglacial cycles, with warmer interludes lasting thousands of years. During these periods, Britain transformed into a temperate grassland, rich in prey and free of permanent ice. At such times, the English Channel was dry, exposing the vast landmass of Doggerland, a rich tundra steppe connecting Britain to mainland Europe. Herds of reindeer, wild horses, red deer, and aurochs roamed freely, and with them came their predators: wolves, lions, and yes, hyenas. Still, questions remain. Hyenas are not built for cold. Their physiology, thin skin, exposed extremities, limited body fat, makes them poorly suited to glacial winters. Yet their fossils appear again and again across Pleistocene Britain, even during periods when cooler climates dominated. Were Ice Age hyenas more cold-adapted than we realize? Did they follow the seasonal migration of prey into Britain during warmer years, only to retreat south when the cold returned? Or did some populations stay, surviving in pockets of temperate refuge, eking out a living in sheltered valleys, deep caves, or coastal plains. The fossil record is strangely rich and strangely selective. In some regions, hyena remains are surprisingly common, outnumbering those of other large predators. In others, they vanish without warning. Their presence is often marked not just by bones, but by highly specific taphonomic signatures, the way they processed carcasses, moved their young, and even defecated. Their dens often resemble crime scenes, bones arranged in seemingly chaotic piles that, under closer inspection, reveal deliberate sorting, skulls here, femurs there, spines untouched. Some researchers propose that hyena behavior may have influenced the distribution of prey bones across the landscape, possibly even impacting the archaeological record itself. Could some so-called human hunting sites, particularly in less explored areas, actually be misidentified hyena kill zones? The lines blur further when one considers sites where hyena and human remains are found together. At several locations, including Wookey Hole and Creswell Crags, human bones bear hyena bite marks. In others, hyena bones appear in layers with Neanderthal artifacts. Did these predators and early humans compete for shelter, for food, for territory? Did they interact directly? Did hyenas scavenge human camps, or did humans hunt hyenas, seeing them as threats? No one knows for sure. As we look deeper, more questions emerge. Why did the hyenas vanish from Britain? By around 28,000 BC, their presence fades from the record. Was it the encroaching cold of the last glacial maximum that finally drove them out? Or did changes in prey abundance, competition from humans and other predators, or disease play a role? Some speculate that their extinction may tie into larger Ice Age disruptions, linked perhaps to the same climatic pulses that triggered glacial floods, megafaunal collapses, and sudden cultural shifts in early human populations. Were they part of a larger domino effect, where the disappearance of one species rippled outward, reshaping entire ecosystems? Others ask a different question altogether. Have we truly found all the evidence? So many of Britain's Ice Age cave systems remain unexplored or underanalyzed, their deeper chambers sealed by collapse or buried by sediment. What might lie within? More dens, more fossils, perhaps even the footprints of cubs playing in ancient mud. What of the ancient myths and legends of monstrous beasts lurking in the hills? Could echoes of Ice Age predators have filtered into local folklore, remembered not by name, but by shape and shadow? The story of Britain's hyenas is not one of misplacement or anomaly. It is a story of adaptation, of ecological complexity, and of a predator that once ruled a land now shrouded in green. They were here, in numbers, for thousands of years. And yet, like so many mysteries of the Ice Age, they vanished, quietly, without explanation. Their dens lie silent. Their bones, broken by their own jaws, still speak. But what, if anything, did they leave behind in us? In memory, in myth, in the ground, still waiting to be opened? Perhaps one day, the caves will answer. Until then, the wind over the moors carries the faint echo of a laughter now long gone. From the denning caves of Britain's Ice Age hyenas, where bone and shadow reveal the subtleties of predator-prey dynamics, we now move into a different kind of enigma, one not traced through migration routes or climate cycles, but through anomalous discoveries that continue to provoke debate. Fossilized footprints too large to fit the frame of known human evolution. Bones long since lost or discredited, but once displayed as proof of another kind of man. This is the quiet puzzle of abnormally large humans, a story written not in mythology, but in stone, sediment, and whisper. In a dry basin near Valley of Fire, Nevada, deep beneath layered volcanic ash and fossilized mud, a series of human-like footprints was uncovered in the 20th century, but these were no ordinary tracks. Some measured over 20 inches in length. The stride was wide. The depth of impression suggested substantial mass. To some, they were dismissed as misidentified bear prints, eroded and stretched by time. But to others, the symmetry and spacing raised questions that were harder to ignore. Similar stories echo across the globe. In Katirka, Siberia, not far from where mammoths lie preserved in permafrost, a femur, human in shape but significantly larger than any modern specimen, was once reported by a Soviet-era archaeological team, only to be lost in transport during political upheaval. In Palestine, early 20th century excavations at Tel Es-Safi unearthed an enormous molar and jawbone, said to belong to a burial far larger than those around it. Again, the artifacts disappeared, recorded in writing but never secured for modern analysis. Are these tales of exaggeration and error, or hints of a forgotten lineage? Mainstream anthropology recognizes variation in human size, from the shorter statures of Homo floresiensis to the tall frames of Upper Paleolithic Cro-Magnons. Height, as a trait, is flexible, influenced by genetics, nutrition, and environment. Some populations, like the Gravettian people of Europe, regularly produced males exceeding 6 feet tall, an impressive height for the Ice Age. But this isn't the mystery. The real enigma lies in outliers, not just tall but exceptionally large individuals, with skeletal proportions that seem inconsistent with known hominins. In North America, 19th century newspapers and early museum records describe giant skeletons unearthed in burial mounds, some over 8 feet in length, with double rows of teeth, elongated skulls, or massive jawbones. These reports, now viewed with skepticism, were often poorly documented and sometimes tied to fringe ideologies or local folklore. And yet, there are patterns, too many to dismiss entirely, too scattered to confirm. What is especially strange is the frequency of such claims in highland or cave-rich regions, places like the Appalachian foothills, the Caucasus Mountains, and the caves of northern Spain. In 1936, a mining team in Ecuador reportedly found a buried skeleton over 7 feet long, preserved in a sealed sandstone chamber. The find was photographed but then removed to private collections. The site was never excavated again. Why do so many of these stories end the same way? Lost artifacts, misplaced bones, archived notes. No clear hoaxes, but no proof either. Scientists who entertain these cases cautiously explore possible explanations. Could some have been examples of gigantism, rare hormonal disorders caused by pituitary abnormalities? The modern medical world offers precedent. Individuals like Robert Wadlow, who stood nearly 9 feet tall in the 20th century, though fragile and requiring braces to walk. But would individuals with such conditions have survived in harsh Ice Age climates? Would they have been buried with honor in ceremonial mounds? And could multiple examples across continents suggest more than just rare pathology? There's also the possibility of cryptic hominin variation. In recent years, discoveries of Homo naledi, Denisovans, and other archaic humans have shown that our family tree is far less linear than once thought. Denisovan DNA found in modern Melanesians and Asians reveals interbreeding with tall, robust ancestors whose physical remains are scant, but whose genetic legacy is real. Could some Ice Age populations have retained traits, tall stature, heavy bone density, massive musculature, not as anomalies, but as adaptive responses to colder climates, greater prey, or higher caloric intake? Or could we be glimpsing a now extinct lineage, closely related to Homo sapiens, yet distinct in form? Then there's the more speculative fringe. Theories of antediluvian civilizations, advanced or otherwise, where giants were not myths but rulers, laborers, or warriors. Legends from the Bible, Sumerian tablets, Norse sagas, and indigenous oral traditions all speak of giant humans, not as monsters but as ancestral figures. The Nephilim of Palestinian texts, the Titans of Greece, the Viracocha of the Andes. Were these merely symbolic representations of power, or distorted memories of real individuals, just outside the expected bell curve? Skeptics point out the lack of verifiable skeletal evidence. No museum today displays a scientifically authenticated Ice Age giant. Peer-reviewed publications on such remains are rare, and those that exist often lean toward reclassification or pathology. Yet the absence of proof is not proof of absence. In the deep caves of Europe, many burial sites remain sealed. In the icy north, layers of permafrost have only just begun to yield their secrets. In forgotten archives and private collections, dusty boxes may still contain the data once overlooked or dismissed. What if the remains of abnormally large humans do exist, misidentified or misfiled in plain sight? This isn't a story of conspiracy or revelation. It's a story of incomplete information, of anomalies, documented but unexplained, of footprints too large, skulls too thick, and femurs that don't quite fit the species we think we know, of a human past that may include more diversity, more range, more exception than our models currently accept. Could Ice Age giants have walked among us? Not myth, but mystery? Not legend, but lineage? Or are we seeing patterns where none exist, stitching together stray bones into stories? For now, the bones stay buried, or lost, or dismissed. But as we dig deeper into our past, we must ask, what defines the limits of humanity? And who decides what is possible? As echoes of oversized footprints and anomalous skeletons fade into the sands of time, we turn our gaze southward toward a silent, sun-cracked basin just beyond the edge of Mexico City. Here, where the soil holds the memory of ancient lakes, one of the most enduring and controversial Ice Age mysteries of the Americas lies buried. A single skeleton, a still body, and 1,000 questions. This is the case of Tepexpan Man. The plain of Lake Texcoco was once a watery expanse teeming with life. Tens of thousands of years ago, it was a fertile wetland, home to mammoths, camels, horses, and early humans navigating a shifting post-glacial world. Today, it's largely drained, paved, and built over, a patchwork of dry lakebed and urban sprawl. But in 1947, a discovery along its shoreline stopped the scientific community in its tracks. A team of archaeologists working near Tepexpan, in the state of Mexico, uncovered a well-preserved human skeleton lying face down in ancient clay beneath layers of volcanic ash and lake sediments. The body appeared deliberate in its position, as though laid to rest. Around it, mammoth bones, traces of obsidian tools, and sediment layers long undisturbed. The bones were male, robust, aged somewhere between 40 and 50 at death, and according to initial estimates, the man had died some 10,000 years ago, possibly more. If true, it would make him one of the oldest human remains found in the Americas at the time. But nothing about Tepexpan Man has ever been simple. From the very beginning, debate surrounded the discovery. Was the skeleton truly that ancient? Were the mammoth bones and tools contemporary with the man, or coincidental? Did the sediment layers guarantee stratigraphic integrity, or had something disturbed the site in the millennia since? Attempts to date the bones using radiocarbon methods produced conflicting results. Some suggested an age of around 11,000 years, aligning with the end of the Pleistocene. Others pointed to a much more recent origin, perhaps as late as 2000 BC. These inconsistencies were often attributed to groundwater contamination or inadequate sampling techniques. Plausible, but unsatisfying. The surrounding archaeological context only deepened the mystery. Mammoth bones at the site bore cut marks, hinting at butchery by humans. Obsidian flakes, tools likely used for hunting or scraping, were found embedded in nearby layers. Some researchers argued that Tepexpan Man may have been a mammoth hunter, possibly killed during a hunt or buried with reverence by his kin. Others questioned whether the proximity of the mammoth remains was meaningful at all. Was this burial ritual or accidental overlap? One of the most curious aspects of the skeleton is its condition. Despite lying in damp sediment for millennia, the bones are exceptionally well preserved, lacking the deformation or decay typical of similar finds. The skull in particular shows clear definition, with strong zygomatic arches and a pronounced brow ridge, more typical of archaic populations than modern humans. The femurs are thick, the vertebrae robust. In life, Tepexpan Man may have stood taller than the average hunter-gatherer of his time, though not excessively so. For years, museum displays confidently presented him as a Clovis-era hunter, a relic of the earliest American inhabitants. His image appeared in textbooks, documentaries, and cultural exhibits, a symbol of Ice Age humanity in the New World. But as technology advanced, so did scrutiny. In the early 2000s, new dating methods, including uranium series analysis, placed the bones at roughly 4,700 years old, a full 6,000 years younger than once believed. Skeptics seized on the data as confirmation that Tepexpan Man had been misdated from the beginning, a post-glacial farmer or herder, not a mammoth hunter at all. And yet, other scientists weren't convinced. Why, they asked, would a relatively recent burial appear beneath sealed layers of volcanic ash clearly dated to the Pleistocene? Why were mammoth bones, long extinct by 4000 BC, so abundant in the surrounding sediment? Was the site disturbed after initial burial? Was the man buried into older layers during a later ritual? Or, more provocatively, could our dating methods be missing something fundamental? Then came an even stranger twist. In 2002, a re-examination of the pelvis and skull suggested something startling. Tepexpan Man may have been a woman. The features once considered robust masculinity were reinterpreted as atypical female traits: broad hips, narrow mandible, pelvic curvature. If true, this would recast the entire narrative, from male hunter to possibly female gatherer, or even spiritual figure. The press dubbed the discovery Tepexpan Woman, but the debate remained unresolved. Others insisted the skeletal morphology still pointed to male. The ambiguity only reinforced a larger truth. This figure, whoever they were, resisted easy classification. A lone individual, caught in the sediment between timelines. Neither confirmed hunter nor dismissed anomaly. Just waiting. Theories about the Tepexpan burial continue to emerge. Some researchers suggest that the individual may have died in a ritual context, deliberately buried in older layers to draw power or meaning from the ancient past. Others wonder whether this could be an example of early cemetery reuse, where newer people interred their dead into the symbolic strata of mammoth hunter ancestors. A few fringe theorists even suggest that Tepexpan Man, or woman, may represent a hybrid population, descended from multiple waves of migration into the Americas. Could this skeleton, with its ambiguous features and controversial context, be a remnant of an unknown lineage, one that came not through Beringia but from the south, or across oceans, long before the Clovis horizon? The mainstream holds its ground. More data is needed, more precise dating, more excavations in the Texcoco Basin. But with each new analysis, the Tepexpan puzzle grows no clearer. Perhaps the most haunting detail of all is the expression on the skull. Calm, untroubled, as if the individual, thousands of years ago, knew something we have since forgotten. Their bones hold a silence deeper than explanation, a silence that resists our timelines, our labels, our attempts at neat historical narrative. So who was Tepexpan Man? A mammoth hunter? A misidentified woman? A misplaced soul? Or simply a mirror reflecting how much of our past remains unclaimed? In the dried beds of ancient lakes, bones do not lie, but they do not always speak clearly either. The earth holds its memory tight, and the answers may still be sleeping beneath the silt. The wind howls across the Yana River basin in northeastern Siberia. The ground beneath is not soil as most know it, but a cement of ice, sediment, and time. In this realm of silence and stillness, where mammoth bones protrude from cliff faces like broken tusks of forgotten titans, life once thrived. Now it waits, buried deep beneath the permafrost. Locked within this icy crypt are not just relics of ancient beasts, but things much smaller, things far more unsettling. Beneath layers of frozen earth, scientists have begun unearthing what should not be alive, but is. In 2014, French researchers revived a virus that had been frozen in Siberian permafrost for over 30,000 years. Under a microscope, it appeared monstrous by modern standards, so large that it was visible using simple light optics. They named it Pithovirus sibericum. Though it posed no threat to humans or animals, its revival sent shockwaves through the scientific world. What else might lie dormant beneath the ice? The discovery was no isolated event. Since then, a string of ancient zombie viruses have been found, each recovered from deeper and older layers of frozen ground. In 2022, a 48,500-year-old virus, Pandoravirus yodoma, was successfully reanimated from a sample taken near a former mammoth hunting site. Unlike bacteria, which can form protective spores, these viruses had endured purely through the preserving cold, encapsulated in the frozen matrix of time. Permafrost covers roughly 24% of the land in the northern hemisphere. In regions like Alaska, Greenland, and Siberia, it acts as both graveyard and vault, preserving organic material, microbial life, and atmospheric snapshots from tens of thousands of years ago. In a sense, it is the Earth's biological time capsule. But what happens when that vault begins to thaw? With global temperatures rising and Arctic regions warming at twice the rate of the global average, the permafrost is no longer stable. As it thaws, it releases not just carbon dioxide and methane, but ancient microorganisms, some of which have not seen daylight since before the dawn of civilization. Among these, viruses are the least understood. We often think of viruses as modern afflictions: Ebola, HIV, SARS, and more recently COVID-19. But viruses are far older than civilization. They predate agriculture. They may even predate multicellular life itself. And the Ice Age may have preserved forms that evolved alongside animals now long extinct. So what would happen if a virus once tailored to infect mammoths still worked? Some researchers believe the risk is low. The genetic pathways of such ancient organisms may be incompatible with modern hosts, but others aren't so sure. Viruses mutate quickly. Some exhibit unexpected plasticity, adapting to new environments with ease. In 2016, a troubling incident occurred in Siberia's Yamal Peninsula. An unusually hot summer thawed decades-old permafrost, exposing the carcass of a long-dead reindeer. Within days, over 2,000 reindeer were infected with anthrax, dormant spores that had lain frozen in the animal's remains. One child died. Dozens were hospitalized. That was anthrax, a known quantity. What if something far older were to emerge? This isn't science fiction. It's an unfolding field of research known as paleovirology, the study of ancient viruses. And with every year of melting ice, the field grows more urgent. At a permafrost dig site in Yakutia, scientists have recovered DNA fragments of unknown viruses from sediment dating back over 100,000 years. Some show no match to existing genetic databases. They are, quite literally, forms of life the world has never seen. Others resemble modern viruses but carry significant genetic divergence, suggesting they branched off from known viral families long ago, during the Pleistocene, or even earlier. What ecosystems gave rise to these ancient viruses? What hosts did they depend on? Could any still exist, waiting for contact? And most pressingly, could any be pathogenic to humans? Researchers tread carefully. Work with revived viruses is done under strict biosafety protocols, often in BSL-4 laboratories, the highest level of containment. But the permafrost itself is unregulated. Melting continues. In places like Norilsk, methane bubbles rise from newly thawed lakes, and in places like Batagay, where a massive permafrost megaslump exposes ancient layers daily, material that hasn't breathed in over 50,000 years now sits exposed to air. Could pathogens be revived naturally? Some say no, pointing to ultraviolet exposure, environmental dilution, or biological incompatibility. But others are more cautious. After all, humanity has no immunity to a virus that hasn't circulated since mammoths roamed North America, or Neanderthals huddled in caves. History has shown how fragile we are when encountering novel microbes. Could the next pandemic arrive not from a distant jungle or wet market, but from the depths of melting ice? More speculative voices suggest even stranger possibilities. Could viruses from the permafrost carry ancient genetic information, messages encoded in biology from ecosystems lost to time? Could they be tools in understanding how life once adapted to extremes, cold, hunger, extinction? Might they even hold clues to ancient pandemics? Ice Age plagues that helped shape the course of evolution, weeding out populations, driving migration, and perhaps even influencing human genetic development? No definitive answers exist, but every new thaw uncovers more data, more unknowns. The deeper we dig, the more we realize how little we understand about our microbial past. The case of frozen viruses in ancient permafrost is not just a mystery of survival, it's a mystery of time, of how long life can wait in stasis and what happens when it wakes. In the age of melting poles and shifting climates, the permafrost is no longer a locked vault. It's opening, piece by piece. So we ask, what else is hidden in the ice, waiting to return? And are we ready for what may come back with the thaw? High in the Altai mountains of southern Siberia, where snow lies thick even in late spring and the wind seems to whisper secrets between the pines, stands a cave carved into limestone. At first glance, it is unremarkable, one of countless dark openings in the rugged hills. But inside this cave, beneath layers of sediment and time, lies one of the greatest enigmas of the Ice Age. This is Denisova Cave, and it holds the ghostly fingerprints of a human lineage we barely understand. In 2008, Russian archaeologists uncovered a small, fragmentary bone deep within the cave. A sliver of finger, smooth and fossilized. It belonged not to Homo sapiens, nor to Neanderthals, but to a previously unknown group of humans. The DNA extracted from the bone didn't match any species known to science. It was something different. They were named the Denisovans, after the cave where their story began. Little remains of them, a molar tooth here, a piece of jawbone there, and that single finger bone. The fossil record is scarce, just a few scattered fragments across Asia. No full skeleton has ever been recovered. And yet, from such sparse evidence, an entire species has emerged into the spotlight of human prehistory. So who were they? Genetic analysis reveals a surprising truth. The Denisovans were close cousins of the Neanderthals, but genetically distinct. They split from a common ancestor some 400,000 years ago, evolving separately in parts of Asia, while Neanderthals occupied Europe and Western Asia. More astonishing still, Denisovan DNA lives on. Modern humans, especially those from East Asia, Melanesia, and Oceania, carry traces of Denisovan genes in their genomes. Some populations in Papua New Guinea have up to 5% Denisovan DNA, suggesting that interbreeding occurred multiple times over tens of thousands of years. But here lies the paradox. We carry their legacy in our blood, and yet we barely know who they were. Why did a people once widespread across Ice Age Asia disappear so completely? Where did they go, and when? Mainstream theories propose that the Denisovans were gradually absorbed into larger populations of Homo sapiens, losing their distinct identity over generations. Others suggest they were outcompeted, slowly replaced as anatomically modern humans spread across Eurasia. And yet, gaps remain. The Denisovan presence stretches from the Altai Mountains to the highlands of Tibet and possibly as far southeast as the Philippines and Papua New Guinea. That's an enormous range for a species we've barely touched in the fossil record. No cave art, no tools definitively linked to them, no burial sites, just a whisper in the stone. Could a people with such wide distribution vanish without a trace? In 2019, scientists discovered a Denisovan jawbone in Brea Tar Cave on the Tibetan Plateau, at an altitude of over 10,000 feet. The find was extraordinary, not just for its location, but for what it implied. The Denisovans had adapted to high-altitude life long before Homo sapiens ever reached such elevations. They carried a variant of the EPAS1 gene, which helps regulate oxygen in the bloodstream. Today, this very gene is found in Tibetans, allowing them to live and thrive at high altitudes. But it didn't come from us. It came from them. What kind of people were they, these mountain-dwelling ancestors? How did they master environments so extreme, yet leave behind so little? Could their way of life have been nomadic, constantly shifting across landscapes in response to climate and resources? Or were they more rooted, living in ways we've simply failed to detect, settlements now hidden beneath permafrost or ocean? Some scholars have proposed that rising sea levels at the end of the Ice Age may have drowned entire Denisovan coastal communities. Much of the world's population during glacial periods likely lived along shorelines that today are submerged beneath hundreds of feet of water. What secrets might be buried off the coasts of Asia? Have we simply not looked in the right places? There are other mysteries, too. In 2012, researchers announced the discovery of a child born to a Neanderthal mother and a Denisovan father, found again in Denisova Cave. This hybrid individual, nicknamed Denny, was direct evidence that these two groups not only coexisted, but interbred. The Denisovans, it seems, were part of a much larger web of Ice Age humanity, exchanging genes, culture, and perhaps language with Neanderthals and Homo sapiens alike. But then, why the silence? Why have we uncovered cave after cave filled with Neanderthal art, tools, and burial sites, but none definitively tied to Denisovans? Is it simply a matter of preservation, or is there something deeper? Could the Denisovans have had a cultural tradition that left few physical traces, relying on wood, bone, or oral knowledge that vanished with them? Some fringe theories have emerged too, speculations that the Denisovans may have ventured farther than we imagine, perhaps even contributing to early megalithic cultures or sailing across prehistoric oceans. There is no hard evidence to support these claims, but the mystery remains alluring. Why does their genetic legacy stretch across such vast regions, while their material culture remains almost invisible? As more ancient DNA is sequenced, the Denisovans seem to become both clearer and more enigmatic. We know more about their biology than ever before, yet less about their minds, their rituals, their beliefs. They haunt the edges of prehistory, present, but ghost-like. Perhaps they disappeared gradually, folded into our expanding world. Or perhaps their disappearance was swift, catalyzed by environmental collapse, volcanic activity, or disease. Could climate shifts at the end of the Pleistocene have fragmented their population, scattering small groups into extinction? We may never know for sure. What we do know is this: we are not alone in our past. The story of humanity is not a straight line. It is a braided river, diverging, converging, and sometimes vanishing into the sediment of time. And somewhere, in that cold shadow of the Ice Age, the Denisovans walked. We carry their blood, but not their stories. What memories are locked inside the stones they touched? And what else waits to be found in the dark corners of forgotten caves? In the parched basin of northern Nevada, where the wind moves like a whisper through sagebrush and time feels thick and unmoving, a dark, gaping cavity cuts into a limestone outcrop. At first glance, Lovelock Cave is unremarkable, just another scar in the rock above the Humboldt Sink. But to the Paiute people, this cave was far more than a geological formation. It was a tomb, a battleground, and the final resting place of giants. According to their oral history, passed down through generations long before pen met paper, there once lived a race of towering red-haired beings called the Site-Ka, ferocious and cannibalistic. These beings, the stories claim, plagued the Paiute ancestors, terrorizing their settlements, stealing their resources, and consuming their dead. The stories reach their climax in fire. The Paiutes, it is said, cornered the last of the Site-Ka in a cave. When negotiations failed, they set fire to the entrance, sealing the giants inside forever. For decades, these accounts were dismissed by outsiders as folklore, a symbolic narrative, perhaps, meant to explain tribal warfare or migration. But in the early 20th century, the excavation of Lovelock Cave stirred new questions and opened the door to a mystery that remains unresolved. In 1911, a team of guano miners working inside the cave discovered something strange. Not bones, at first, but artifacts. Duck decoys, woven baskets, wooden tools. These were not the crude implements of primitive life, but items of craftsmanship, some dated later to be over 2,000 years old. Archaeologists were brought in, and soon the cave yielded more. Over 10,000 artifacts, many preserved in astonishing condition due to the dry, alkaline climate. Then came the human remains. Among the finds were several unusually large skeletons, with femurs longer than average and skulls said to be abnormally large. Early reports, particularly those echoed by Lovelock locals and early researchers, mentioned tufts of reddish hair still clinging to some of the skulls. To the Paiutes, this was no surprise. Their stories had always described the Site-Ka as red-haired giants. But could there be any truth to such a legend? The official archaeological interpretation remains cautious. The larger skeletal remains are considered within the natural range of human variation, and the reddish hair, a likely result of environmental bleaching or pigment degradation, dark hair turning red with age, as is common in mummified remains. Still, questions linger. Several of the skeletons were reportedly over 7 feet tall, well beyond the average height for native populations in the region. The artifacts found alongside them, bone awls, inscribed stone tools, even what appeared to be sandals sized for exceptionally large feet, suggest a community with a distinct material culture. And what of the cave's contents that went unrecorded? Many early reports describe how miners destroyed or discarded bones while collecting bat guano for fertilizer. Some even claim entire skeletons were taken as curiosities and have since disappeared, lost to private collectors or simply misidentified in early museum archives. Could valuable clues have been lost forever in the cave's early disturbances? The intrigue deepens with reports from early researchers like Llewellyn L. Loud of the University of California, who co-authored the first comprehensive study of Lovelock Cave in the 1920s. While his work focused primarily on the artifacts, his notes include mention of large bones and unusual burial conditions. Over the decades, fringe theorists and alternative historians have seized upon these anomalies, weaving them into narratives of lost races, pre-flood civilizations, or even prehistoric visitors from unknown lands. Some suggest that the Cte-Ka were survivors of a forgotten migration, remnants of a Proto-European population, citing similarities between the Lovelock skulls and Caucasoid cranial features. Others have proposed more fantastical explanations, from Nephilim to extraterrestrial hybrids. But mainstream science maintains a firm boundary. While acknowledging the importance of the site, it does not accept the existence of giants, biologically or historically, as anything more than misinterpretation or mythologizing. And yet, the oral traditions remain. The Paiutes still tell the story of the red-haired cannibals who once roamed the land. They do not call it legend. They call it history. In 2013, new studies revisited some of the materials from the cave using modern radiocarbon dating and genetic analysis. The results confirmed the antiquity of the artifacts, some over 4,000 years old, but did not conclusively tie the human remains to any unusual lineage. Still, a comprehensive DNA survey of the large skeletons, assuming any still exist, has yet to be made public, if conducted at all. This leaves us in a familiar place, a mystery suspended between folklore and fact. Did the cave simply house a tall, isolated group of early Native Americans, whose story grew in the telling over centuries? Or did the Paiute legends encode a forgotten encounter with a population now lost to history? An Ice Age remnant, perhaps, or a people displaced by climate and conflict? Could red hair be a vestige of interbreeding with an unknown group? Maybe even Denisovan, whose genetic legacy is still being uncovered in Asian populations? Or is it nothing more than oxidized black hair exposed to desert air? The artifacts, the skulls, the cave itself, all exist. But their full story remains elusive. What really happened in the shadows of Lovelock Cave? Are the tales of the Cte-Ka pure myth, or echoes of a confrontation so ancient that science has yet to catch up? As we continue our journey through the mysteries of the Ice Age, one thing becomes clear. History is not always written in stone. Sometimes it is whispered on the wind, buried in dust, or burned into the memory of a people who refuse to forget. In the desolate tundra of northern Siberia, where wind sculpts ice into quiet monuments and the soil never truly thaws, the earth hides something strange beneath its frozen skin. Patterns, geometric, precise, and inexplicably regular, etched not by human hands, but seemingly by nature itself. They are known as ice wedges, but to the trained eye, they are far more than mere cracks. From the air, they resemble giant fans or angular scars, often running in parallel lines or repeating chevrons across thousands of acres. Some extend meters deep into the permafrost, their presence detectable only after thawing or during excavation. Others form polygonal webs so vast they can only be appreciated from satellite imagery. At first, they seem like a well-understood geological feature. Scientists believe that most ice wedge polygons are created over centuries through the repetitive freeze-thaw cycle of groundwater. The surface cracks in extreme cold, water fills the gaps during the brief summer melt, and over time those veins of ice expand, deforming the surrounding soil into distinctive shapes. And yet, not all is so easily explained. Some formations, particularly those found in Alaska, Siberia, and parts of northern Canada, defy expectations. In these remote regions, researchers have uncovered wedge-shaped troughs, buried deep in the permafrost, that don't always follow the typical ice wedge formation process. These structures, some dating back over 20,000 years, often appear where such freeze-thaw patterns should not have had time to develop or persist. Even more curious, in certain locations, the wedges do not contain ice at all. Instead, they are filled with stratified layers of sediment, charcoal, or even ash. Their walls are unusually smooth, their orientation strangely consistent, and some are nearly indistinguishable from deliberately engineered cuts, like ancient trenches that have frozen in time. This raises a question few dare to ask directly. Could some of these formations have a different origin entirely? Mainstream geology offers possible explanations. It's proposed that these pseudo-wedges may be remnants of ancient mudflows, collapsed tunnels, or even dried root casts from massive prehistoric vegetation. Others may have been influenced by seismic activity or volcanic tremors during the late Pleistocene. But not all experts agree. A handful of geologists have quietly noted the uncanny regularity of some wedge patterns. The fact that they repeat with such mechanical precision, uniform angles, matched spacing, and directional alignment across widely dispersed terrains, has led some to speculate about unknown environmental forces or processes no longer active in the present era. Some even raise the possibility that they may be markers of a vanished technology, not necessarily tools of steel or machines, but perhaps early human attempts at irrigation, boundary setting, or even ritual land carving, preserved by a stroke of climatic luck in the permafrost. The evidence, of course, is circumstantial, but the mystery remains difficult to ignore. In 2014, a joint Russian-American study documented unusual wedge features in Yakutia, a region of eastern Siberia infamous for its extreme cold. Among their findings was a patterned ground structure that resembled an enormous radial fan, with wedges fanning outward from a central point like the spokes of a wheel. The scientists noted the near-perfect geometry of the formation and the absence of expected ice content. What natural process creates such precision without the chaotic irregularities typically found in freeze-thaw cycles? And why are similar features echoed across continents, from the Canadian Arctic to remote valleys in northern Mongolia? Some researchers have pointed out that the permafrost itself may be preserving a story far older than we can currently read. Just as fossilized pollen can tell us about ancient climates, these wedge markings may hold clues to prehistoric landscapes, climates, or even civilizations we've not yet identified. Could it be that some of these features are survivors of the Ice Age's lost architecture, erased everywhere else but frozen here, preserved by millennia of silence? Of course, not all theories stay within the bounds of academic caution. A few independent investigators, drawing from local folklore and aerial surveys, have proposed bolder ideas that the wedge formations are geoglyphs, similar in scale to Peru's Nazca lines, carved into the earth by an ancient and forgotten culture. According to these fringe views, the formations may have served as calendars, star maps, or directional markers, possibly even visible from the air, though the Ice Age would have predated any known form of flight. Skeptics dismiss these claims as pareidolia, our human tendency to find patterns in randomness. After all, nature is no stranger to symmetry. From honeycombs to snowflakes, beauty and order can emerge without design. And yet, the idea lingers. Not because it's provable, but because it reflects a broader truth, that we still do not fully understand the story written into the permafrost. What remains unsettling is not just the shape of these markings, but their timing. Many wedge features appear to have formed near the end of the last glacial maximum, roughly 20,000 to 12,000 years ago, coinciding with a period of extreme climate instability. This was the same epoch that saw the disappearance of mammoths, the vanishing of the Clovis culture, and the controversial evidence of catastrophic flooding and rapid warming. Were these formations the byproduct of an Earth in upheaval? Or were they part of a human response, an effort to mark, measure, or somehow harness the changing landscape? And if so, what was the purpose? Could the Earth itself be keeping secrets beneath its frozen skin, patterns shaped not only by frost, but by forgotten hands? As satellites continue to scan the remote north and the permafrost melts at unprecedented rates, we are entering an age of revelation. What was once locked away by ice may now return to the surface, and with it, the faint outlines of mysteries we didn't even know to ask. What story do these strange wedge-shaped marks tell? And how many more wait, invisible, just beneath our feet? In the vast, desolate whiteness of Greenland's interior, silence reigns. Here, the land is buried beneath more than 2 miles of ancient ice, layered like the pages of a book that's never been opened. The wind scrapes across the ice sheet in long, low whispers, as if the Earth itself is trying to remember something it once knew and buried. For decades, scientists have drilled into this frozen expanse, extracting narrow cylinders of compacted snow and ice known as ice cores. These cores, some stretching over 3,000 meters deep, contain tiny bubbles of trapped atmosphere, dust, volcanic ash, and isotopic signatures that provide an unbroken record of Earth's climate going back more than 130,000 years. Each layer tells a story. The winter snows, the summer thaws, the ash from far-off eruptions, the chemical fingerprints of solar changes. In theory, the deeper the layer, the older the climate snapshot. But the story told by the Greenland cores is not always a steady, predictable one. Sometimes, the book seems to skip a chapter, or add one that doesn't belong. At first, the Greenland ice cores appeared to validate the standard models of glacial-interglacial cycles, patterns of warming and cooling, stretching over tens of thousands of years, matched neatly with those seen in deep-sea sediment cores and Antarctic records. But then, researchers noticed something odd. In cores like GRIP, Greenland Ice Core Project, and GISP-2, Greenland Ice Sheet Project 2, certain layers showed evidence of extremely abrupt temperature shifts, not over centuries or even decades, but within a single year. These were not gradual transitions. They were sharp, violent, and global in consequence. One such event occurred around 12,800 years ago, a sudden return to near glacial conditions after the planet had begun to warm. This anomaly, known as the Younger Dryas, was already puzzling, but in the Greenland ice, it appeared almost instantaneous, a flip of a switch. How could climate, something governed by oceanic currents, planetary tilt, and solar output, change so fast? Some scientists suggest that this was due to massive meltwater pulses from glacial lakes like Lake Agassiz, which disrupted the Atlantic meridional, overturning circulation. Others point to a volcanic eruption or a feedback loop of atmospheric methane. But the ice core record complicates those ideas. In addition to sudden cold snaps, the cores contain layers with unexplained spikes in dust, anomalous isotopes, and chemical signatures suggestive of cosmic input, such as elevated levels of iridium, platinum, and even hints of nanodiamonds. These elements are rare in Earth's crust, but common in asteroids and comets. Could it be that something from space disrupted the climate? The so-called Younger Dryas impact hypothesis proposes that a fragmented comet struck, or airburst over, North America, triggering fires, atmospheric cooling, and a global ecological collapse. Greenland's ice cores, some argue, hold traces of this impact. But here's where things grow stranger. Not all ice core anomalies align with known Earth events. Around 11,600 BC, just as the Younger Dryas ended, another abrupt shift occurred. A dramatic warming that, again, seems to unfold over mere years. This warming marked the beginning of the Holocene epoch, the age we still live in. And it was as sudden as the cooling that preceded it. In the cores, the signal is clear: a sharp rise in oxygen-18 isotopes, indicating a rapid jump in temperature, possibly by as much as 10 degrees in a decade. Mainstream explanations offer ideas: recovery of oceanic circulation, stabilization of ice albedo feedbacks, but no definitive cause. And curiously, this shift corresponds with flood legends and civilizational origin myths across the world. From Sumer to Mesoamerica, India to the highlands of Scotland, cultures recount an era of destruction followed by rebirth. Coincidence? Or has the ice preserved a memory our ancestors encoded in story? Adding to the mystery, some Greenland ice core data has suggested temperature fluctuations that contradict expected solar cycles. While the sun certainly plays a role in long-term climate, certain isotopic records, particularly levels of beryllium-10, suggest periods of intense cosmic ray influx or magnetic disturbances that don't align cleanly with solar minima or maxima. Was Earth's climate being influenced by forces beyond our current models, galactic events, shifts in the magnetic field, or something closer, perhaps atmospheric chemistry influenced by volcanic or extraterrestrial inputs? And then, there's the matter of missing layers. In some core sections, researchers have noted what appear to be compressed or absent annual strata, as though time itself has been squeezed or erased. Ice that should contain 50 years of deposition shows only 30 or 20. No one fully agrees on why. Could this be the result of temporary halts in snowfall, ice compaction artifacts, or did something erase a portion of Earth's history, quite literally scraped from the record? A recent reanalysis of Greenland's Neem core, North Greenland Eemian ice drilling project, introduced further ambiguity. Researchers discovered that parts of the core dating to the Eemian interglacial, over 120,000 years ago, showed unexpectedly warm and unstable periods, with fluctuations that challenge our understanding of stable interglacials. This isn't just academic. If Earth's climate system is capable of flipping that quickly, triggered by unknown or rare forces, it complicates everything we think we know about climate prediction, resilience, and historical causality. What are the Greenland ice cores really telling us? Are we simply decoding a natural system far more complex than anticipated? Or are we stumbling upon episodes of disruption, from above, from within, or from ancient catastrophes now forgotten? Are these sudden temperature jumps the result of impacts, atmospheric instability, or evidence of something more difficult to quantify, events that left no smoking crater but changed the world all the same? The ice remembers what we have forgotten. As technology advances, new cores are being drilled deeper, farther, and with greater resolution than ever before. Each one is a clock, a witness, a secret keeper. But even as we extract data from Greenland's ancient heart, the interpretation remains elusive. What else lies frozen beneath the silence? And when the next anomaly is discovered, will we recognize its significance in time? High in the snow-clad ridges of the Altai Mountains, where Russia, Mongolia, China, and Kazakhstan converge, the wind whispers through pine forests and limestone cliffs that have stood for tens of thousands of years. These rugged peaks are silent sentinels of an ice age long gone. But beneath their surface, deep inside ancient caves, lie secrets that may rewrite the story of human origins. One cave in particular, Denisova Cave, has become the epicenter of one of the greatest mysteries in paleoanthropology. From the outside, it is unremarkable. A shadowed mouth in a rock wall, partially hidden by trees, blanketed by seasonal snow. But within its sediment-rich floors, layer upon layer of ancient history has been meticulously preserved. Here, in 2010, scientists uncovered a single finger bone, small, broken, and nearly overlooked. Yet, when this fragment was analyzed, it revealed something astonishing: a genetic signature unlike any known human group. This bone did not belong to a Homo sapiens or a Neanderthal. It belonged to a previously unknown species of archaic human, now known as the Denisovans. Who were they? And how did they vanish so completely? What makes Denisova Cave truly extraordinary is not only the discovery of a new human species, but the fact that 3 distinct hominin groups, Denisovans, Neanderthals, and modern humans, occupied this single location at different points across tens of thousands of years. Carbon dating suggests that Neanderthals lived in the cave as far back as 120,000 years ago, with Denisovans arriving shortly after, and Homo sapiens eventually appearing in the same stratigraphic layers around 45,000 years ago. This convergence defies prior expectations that these species lived largely isolated from one another. So what happened in the shadows of the Altai? Did these groups encounter one another? Did they trade tools, share firelight, compete for territory, or even interbreed? DNA extracted from the Denisovan finger bone and other fossils has added layer upon layer of complexity. Their genome reveals a species distinct from Neanderthals, but closely related, both descending from a common ancestor hundreds of thousands of years earlier. And yet, Denisovan DNA did not vanish with them. Today, up to 5% of the DNA of some modern populations, especially among Melanesians, Aboriginal Australians, and certain Southeast Asian groups, contains traces of Denisovan ancestry. Meanwhile, most non-African humans carry between 1% and 2% Neanderthal DNA. This overlapping legacy suggests something more than coincidence. It implies intimate contact, repeated encounters, shared offspring, and long, complex relationships between these now extinct branches of humanity and our own. Perhaps most fascinating of all is the discovery of a child, known simply as Denisova 11, whose genome revealed her to be a first-generation hybrid, born of a Neanderthal mother and a Denisovan father. Found in the same cave, her remains represent direct evidence of interbreeding in the deep past. But what was life like for this child of 2 worlds? Did she belong to either group? Was she an anomaly, or one of many such hybrids whose stories are lost to time? Beyond the bones and genes, the cave holds artifacts, finely crafted tools, pendants, and pierced animal teeth. These items suggest intelligence, creativity, and culture. Some archaeologists even argue that the Denisovans were technologically advanced, at least on par with early Homo sapiens. But if that were true, why did they vanish? Why does their presence vanish from the archaeological record so suddenly? Some suggest environmental pressures, a changing climate, dwindling food sources, or the sheer cold of the Siberian winters. Others point to competition with expanding Homo sapiens, whose adaptability and social cohesion may have given them an edge. And then there's the genetic evidence hinting that Denisovans were more widespread than their few bones suggest. Their DNA appears in populations as far south as Indonesia and Papua New Guinea, and possibly even Tibet, where adaptations for high-altitude living in modern Tibetans appear to have been inherited from Denisovans. Could it be that they occupied vast regions of Asia, living unseen by archaeologists? Are their bones still waiting to be discovered beneath the frozen soil of Central Asia, or submerged under ancient floodplains? And what of their relationship with Neanderthals? The same cave shows alternating layers of Neanderthal and Denisovan occupation, suggesting that they may have returned to the cave in different periods. Were they allies or adversaries? Did they compete for this sheltered haven in the mountains? There are no signs of violence, no mass graves, no burned layers indicating conflict. But there are signs of shared space, possibly shared rituals, perhaps even shared languages. As for Homo sapiens, our presence here remains fleeting. A single molar, a few tool fragments. But we would come to dominate the world these other species once roamed. And yet, they remain with us, in our DNA, in our stories, in the archaeological layers of a lonely cave in the Altai. So, what really happened in this quiet place so long ago? Was Denisova Cave a crossroads, a sanctuary, or a battleground? Did we absorb these other humans through peaceful integration, or push them to extinction? And why do so few physical remains of the Denisovans exist, despite their clear genetic influence across Asia and Oceania? The sediment may hold more answers. New methods like sedimentary DNA analysis are beginning to detect human traces without the need for bones, a revolutionary shift that could reveal more hidden presences in the Altai and beyond. The mystery of the Denisovans, their overlap with Neanderthals and Homo sapiens, and their sudden disappearance remains one of the most haunting enigmas of the Ice Age. How many more stories lie buried in the ancient Earth, waiting to be uncovered? And if the Altai Mountains served as a meeting point for 3 intelligent species, could other forgotten chapters of human history still be hidden in caves, mountains, or deserts elsewhere? We may not have reached the end of this story, only the beginning. As we leave the glacial peaks of the Altai Mountains behind, the landscape shifts southward into the dense, steaming jungles and open savannas of the Americas. Here, long before humans carved petroglyphs or raised cities, the land trembled beneath the slow, deliberate footsteps of giants. Imagine standing in what is now the Argentine Pampas, or the basin of the Amazon, 15,000 years ago. Towering above you, not a predator, but a peaceful colossus, an animal the size of a modern elephant, covered in shaggy fur, moving with a lumbering grace. This was Megatherium, one of the largest species of giant ground sloths, a creature that defied the very notion of what a sloth should be. Its long, curved claws, more like scythes than fingers, were capable of pulling down tree branches, ripping apart tough vegetation, or, some speculate, serving as a last line of defense. Standing on its hind legs, it could reach over 20 feet in height, and yet it was herbivorous, seemingly passive, a living relic of a slower, older Earth. But today, there are no Megatherium, no Erematherium, no Glossotherium. Like mammoths, saber-toothed cats, and other megafauna of the Pleistocene, they are gone. The question is, why? The disappearance of the giant ground sloths is part of a larger pattern, a mass extinction of large animals that occurred across the globe between 15,000 and 10,000 years ago, at the close of the last ice age. But the case of the ground sloths is particularly haunting, not just because of their size, but because of how abruptly and mysteriously they vanished. Their fossils are found in abundance throughout South America, Central America, and parts of North America. In Florida, fossilized dung has been preserved in caves. In Chile and Argentina, researchers have uncovered complete skeletons. And most curiously, in some caves in the Caribbean, bones of giant ground sloths are found alongside human artifacts, suggesting a far more recent survival than once believed. In fact, on islands such as Cuba and Hispaniola, some species of ground sloths may have survived until as recently as 4,000 years ago, long after the pyramids of Egypt had been built. If true, this would mean that ancient humans not only coexisted with these creatures, but perhaps even witnessed their final days. Mainstream theories point to a combination of climate change and human hunting. As the Ice Age ended, global temperatures rose, reshaping ecosystems. The massive ice sheets that once blanketed the northern hemisphere retreated. Forests replaced tundras. Rain patterns shifted. These changes may have stressed the food supply of large herbivores like the ground sloths, making them more vulnerable to other pressures. Then, there were the humans. Evidence from sites in North and South America suggests that early human populations, equipped with spears, atlatls, and coordinated hunting strategies, may have preyed upon giant ground sloths. Cave paintings in Brazil seem to depict large sloth-like animals being pursued by hunters. Cut marks on sloth bones have been found at multiple archaeological sites, but were humans solely responsible for their extinction, or was something else at play? Some scientists argue that the sloths were already in decline before humans ever reached certain parts of the Americas. Others suggest that their slow reproductive cycles made them particularly vulnerable, unable to recover from even moderate hunting pressure. Still, the puzzle remains. Why did smaller, more agile species survive the Ice Age while these giants, some of whom lived in remote, less accessible regions, did not? And what of the evidence suggesting that ground sloths survived much later than previously thought? In 2016, a team studying the dry caves of Belize uncovered what appeared to be human footprints alongside the claw prints of a giant sloth. Even more intriguing, some of the sloth tracks showed hesitation, as if the animal had turned or reared back, leading some to speculate whether the humans were stalking or cornering it. Could this be a snapshot of a final, fatal encounter between species? Or is it possible that humans and sloths developed a more nuanced relationship, one of mutual avoidance or even respect? In the high Andes, Incan legends speak of ancient beasts that roamed the mountains, hairy, slow-moving creatures that could tear down trees. Though likely mythologized, such oral histories may preserve distant memories of real animals seen by human ancestors. Even today, deep in the Amazon rainforest, there are whispered stories among indigenous tribes of massive, shaggy creatures seen only at a distance. Some cryptozoologists suggest these may be cultural echoes of extinct sloths. Of course, no living evidence has ever been found, but the jungles of South America are vast, and much of their interior remains largely unexplored. Could an isolated population have survived longer than science believes? Or is this simply another example of myth filling the void left by memory? The preservation of sloth remains has also yielded surprising data. In some caves in the Caribbean, sloth bones appear untouched by predators or humans, suggesting they died not from hunting, but possibly from starvation, illness, or environmental catastrophe. Could a disease have swept through their population, or a sudden climatic shift? Others have asked if cosmic or geophysical events, such as the proposed Younger Dryas impact or changes in Earth's magnetic field, may have destabilized ecosystems in ways we have yet to fully understand. And yet, amid all the hypotheses, we're left with silence. The sloths are gone, but their bones lie scattered across the continent, their stories half told. Each fossil, each cave, each track frozen in ash or mud is a fragment of a mystery that defies simple answers. Did we end them? Did the Earth change too quickly for them to survive? Or was their extinction the result of a chain of events so complex we're only just beginning to trace its outline? The giant ground sloths were not monsters or myths. They were real, living beings who once shaped the landscape as profoundly as mammoths or bison. Their loss is not only a biological mystery, it is a narrative break, a moment when one chapter of life ended and another began. What other stories ended in that quiet, hidden way? And what other truths might still lie buried beneath the soil, waiting to rise again from the shadows of the Ice Age? As the echoes of vanished giants fade into the cold winds of prehistory, we travel north, where ice still clings stubbornly to the land. The landscape changes, the air turns sharper, the ground beneath our feet hardened by centuries of frost. Alaska, a vast, untamed frontier where glaciers cut across valleys like rivers frozen in time, holds secrets of its own. Here, in places where ice once reigned supreme, something extraordinary has begun to emerge. Near the base of Alaska's melting glaciers, where icy tongues retreat under the warming breath of a changing climate, dark stumps rise from the gravel like ancient totems. Their bark is gone, but their shape remains intact. Some still stand upright, roots clutching soil that hasn't seen the light of day in over 1,000 years. These are not modern trees that died and fell in place. They are the remnants of a prehistoric forest, long entombed beneath glacial ice. And their preservation is so precise, so sudden in appearance, that scientists have paused to ask, what exactly are we looking at? The discovery of these forests began quietly in the early 2010s as glaciers like the Mendenhall in southeast Alaska began to shrink at unprecedented rates. Hikers and researchers noticed unusual formations appearing at the glacier's edge. What looked like driftwood at first revealed itself to be upright trees, still anchored in the positions where they once grew. Carbon dating placed many of these specimens at over 1,000 to 2,000 years old, with some suggesting even older periods, stretching back to the mid-Holocene. These trees, likely part of a thriving spruce or hemlock forest, had been buried under ice not by the slow, creeping advance of a glacier, but seemingly by a more sudden event. Some of the trees show signs of bark damage or rapid burial, and many remain standing. What kind of force could cover a forest so quickly and so completely, preserving it for millennia beneath compacted snow and ice? Mainstream glaciology provides a reasonable explanation. As the climate shifted during the Little Ice Age, glaciers advanced down from the mountains, overtaking valleys and lowland forests. Over time, snow compacted into ice, burying the trees where they stood. This process, though slow by human standards, is relatively fast on a geologic timescale. The trees were sealed away, protected from oxygen and bacteria, preserved as if nature herself had placed them in a vault. But this explanation raises deeper questions. If this was simply a glacial advance, why are some of the forests so well preserved, intact, upright, and with organic material still clinging to the roots? And why do some areas show multiple layers of buried forest, stacked like pages in a forgotten book? Could this point to not just one encroachment of ice, but several? A cycle of warming and freezing, of forests rising and falling beneath the weight of an earth in flux? And then there is the question of timing. If these forests were alive just 1,000 years ago, what does that say about the climatic instability of the region? How quickly can an entire ecosystem be swallowed by ice? Among Alaska's indigenous peoples, stories have long circulated about changes in the land, about forests that disappeared under sudden snow, or spirits sealed beneath ice. Oral traditions passed down through generations sometimes describe rivers turning to stone, or hunting grounds that became dangerous, haunted places where the ground shifted beneath the feet. Are these tales metaphor, or fragmented memories of real geological upheaval? In other parts of the world, the discovery of buried forests has sometimes been linked with more cataclysmic theories, sudden volcanic eruptions, landslides, or even asteroid impacts. In the Pacific Northwest, similar ancient forests have been found beneath lahar deposits, remnants of past eruptions from Mount Rainier or Mount St. Helens. Could Alaska's buried forests be a record of sudden upheaval, not just climate change, but geological violence? There are also more speculative theories. Some researchers have proposed that rapid shifts in Earth's climate might not always be gradual, but could come in sudden pulses, triggered by changes in ocean currents, solar cycles, or even external impacts. The idea is not widely accepted, but it lingers at the edge of scientific debate. Others, peering into the deeper mystery, ask whether these forests might hold clues to older civilizations, lost communities that once thrived in areas now considered uninhabitable. If forests once grew where glaciers now dominate, could people have lived there too? Could artifacts, tools, or even entire settlements lie buried alongside these trees, yet to be unearthed? The region is largely unstudied beneath the ice, and as glaciers continue to melt, more secrets may emerge. What we do know is this: the forests were real. The trees lived and died and then were forgotten. Until now. Some stand as if frozen mid-movement, limbs outstretched toward a sky that no longer exists. And their reappearance is not symbolic. It's tangible. A warning, perhaps. A reminder of Earth's volatility, its ability to rewrite its own story in layers of sediment and frost. Each new exposed stump challenges our understanding of the land's past. Was Alaska once warmer, wetter, and more hospitable to life than we assumed? Were ancient climates more variable than we've ever recorded? And could these forests be just the first chapter in a much larger narrative of hidden ecosystems, not just in Alaska, but beneath every glacier on Earth? As we watch these icy giants recede, we are not just witnessing the effects of modern climate change. We are excavating memory, peeling back the layers of a living planet, uncovering whispers of what came before. The question is no longer whether there are ancient secrets buried in the ice. The question is, how many and how much longer will they remain hidden? And as each glacier melts, slowly revealing the preserved skeletons of lost forests, one can't help but wonder, what else lies beneath, waiting patiently to be seen again for the first time in thousands of years? As ancient forests slowly emerged from beneath Alaska's melting glaciers, they raised a profound question. What else lies entombed in the Earth's frozen vaults, forgotten, fossilized, and preserved against time? To find the answer, we descend deeper, not just into the ice, but into the ground itself. Far from the forests and valleys of the north, in caves and quarries scattered across continents, archaeologists have uncovered something wholly unexpected. Tools, pits, shafts, and traces of activity that seem far too advanced for the time periods in which they appear. Welcome to the strange and little-known mystery of Ice Age mining operations, a subject that has puzzled scientists, historians, and theorists alike. In the heart of modern-day Hungary, deep within the Buk Mountains, lies the Lovelock site. Discovered in the 1950s, it appears unremarkable at first glance, just another patch of hillside disturbed by quarrying. But beneath the soil, archaeologists uncovered layers of red ochre, systematically extracted, transported, and processed. Carbon dating of associated materials placed the mining operation at around 12,000 BC, squarely in the late Paleolithic, during the last phases of the Ice Age. This wasn't a case of surface collection. Trenches and pits had been dug into the earth. Stone tools used for extraction were found nearby, alongside signs of grinding and refining. The red ochre, a rich iron oxide pigment, was likely used for ceremonial, decorative, or symbolic purposes. Some scientists even suggest it may have played a role in early sun protection or burial rites. But this discovery opened a deeper mystery. How widespread were such operations? And just how organized were the people behind them? Across Europe and Asia, the evidence begins to accumulate. In Wales, the site of Lovelock Cave, dated to roughly the same era, revealed not only elaborate burial practices involving ochre, but also signs of material extraction from nearby limestone formations. In the Altai mountains of Siberia, caves long associated with Denisovan and Neanderthal activity show residues of mineral collection, specifically manganese and hematite. In South Africa, The Bomvu Ridge mine has produced compelling evidence of ochre extraction going back more than 40,000 years. And in Australia, Aboriginal mining activity at the Wilgi-Mia ochre mine dates to at least 30,000 BC, an astonishing span of time. These operations suggest not isolated incidents, but an enduring tradition of resource gathering, spanning continents and cultures. So the question arises, how did these ancient people develop such widespread and organized mining behaviors, seemingly in parallel? Mainstream archaeology points to practical explanations. Red ochre had symbolic and ritual value across early cultures. Its color, blood-like, vibrant, and enduring, likely held deep meaning to our ancestors. And its collection and use, while labor-intensive, would have been within reach of Paleolithic communities given enough time and persistence. But the depth, precision, and distribution of some of these mining sites has prompted more speculative inquiries. In some locations, shafts extend meters into the ground, dark, narrow, and reinforced. This raises a logistical puzzle. How did Ice Age people light these tunnels? No soot has been found on the walls of certain sites, ruling out traditional torches or open flames. Could they have used reflective surfaces, animal fat lamps, or other unknown techniques? In a few cases, evidence suggests ventilation and planned shaft placement to avoid collapse, an understanding of underground engineering far ahead of its time. Some theorists propose an even stranger question. Was this mining purely for symbolic materials like ochre, or were they after something else entirely? There are fringe theories, unproven but intriguing, that suggest certain mineral deposits, such as crystalline silica or rare earths, might have had uses we've yet to fully understand. Could Ice Age peoples have discovered rudimentary energetic or medicinal applications for these materials? There is no evidence of metallurgy from that period, but then again, absence of evidence is not evidence of absence. Others point to the similarity between mining patterns in distant regions. The systematic way ochre was sought in France, Australia, and Central Asia, often in cave networks or subterranean pits, raises the possibility of a shared practice passed between distant groups. But how could ideas like this travel so far, especially in an Ice Age world thought to be fragmented and harsh? Then there is the possibility that we are simply underestimating early human cognition. The people of the Ice Age weren't primitive in thought, only in technology. Their minds were as complex and capable as ours, perhaps more attuned to natural patterns and materials than modern humanity. And so, the red stains left behind in ancient mines might not be remnants of mystery, but fingerprints of forgotten brilliance. Of course, the skeptic will ask, if mining was truly widespread, where are the remains of the communities that supported it? Where are the tools, the storage sites, the cultural footprints? Some of these traces do exist, but they are faint, fragmented, and often dismissed. Sites like Blombos Cave in South Africa show clear signs of ochre processing alongside shell bead production, suggesting an early connection between mining, art, and perhaps trade. In Paleolithic Spain, ochre-stained bones and cave walls hint at shared symbology spanning generations. Could these mines have been proto-industrial centers of a kind we've never recognized? Or were they sacred spaces, entered with reverence, dug not only for utility, but for communion with the earth? In the end, we are left with more questions than answers. What drove these early people, scattered across a frozen world, to dig deep into the earth in search of red pigment? What did they see in the ochre, in the minerals, in the rocks themselves? Were they merely artists and ritualists, or early engineers and alchemists of a forgotten kind? As glaciers melt and archaeologists probe deeper into the foundations of time, new mines are still being uncovered. Some buried beneath landslides, others hidden in cave systems never fully explored. Each one tells a fragment of a story whose full meaning remains just out of reach. Could it be that beneath the dust of ages, a lost chapter of human ingenuity lies waiting? If so, perhaps the answers are not in the stars, but buried in the rock beneath our feet. From ochre-stained tunnels carved beneath the Paleolithic earth to the glittering frost of forgotten glacial valleys, the Ice Age reveals itself not through monuments, but through remnants. As our journey presses on, we leave behind the quiet hum of ancient mines and step into a more haunting silence, one defined not by what was built, but by what was left behind. Scattered across desolate tundras, hidden in secluded caves, and buried beneath wind-blasted sediment, researchers have uncovered a peculiar phenomenon: remote caches of animal bones, collections unlike typical hunting debris or random scavenger deposits. These caches raise a curious question: who or what gathered them? And why were they hidden away in places so distant from known habitation zones? In the frozen expanse of the Ural Mountains, where icy winds still echo through deep ravines, a cave known as Medvedja Cave revealed an unusual discovery. Thousands of animal bones, mostly cave bears, were piled in distinct layers. Some showed cut marks, signs of intentional processing. Others were unbroken, pristine, stacked as if placed with care. The bones were dated to the late Pleistocene, around 30,000 to 40,000 years BC, a time when glaciers ruled the north and early humans, Neanderthals, and possibly even Denisovans wandered the margins of ice and stone. But what startled researchers wasn't just the volume of remains. It was the order, the way they were clustered. The fact that many of these caves lacked the soot or habitation traces typically associated with human activity. It suggested that people, or some other force, brought these remains here on purpose, not as part of a meal or shelter, but for reasons still unknown. Elsewhere, in the Canadian Yukon, researchers found isolated bison and mammoth bones in areas far from active kill sites. Some caches had bones that appeared deliberately arranged, and while scavenger animals, like wolves or hyenas, can transport bones, the pattern of movement over rough terrain into sheltering hollows suggested more than instinct. In southern France, particularly within the Grotte de Chauvet and other deep cave systems, skeletal remains were discovered in positions suggesting ritual placement. These weren't just leftovers from a feast. They were set apart, curated in a way that defied randomness. Why would Ice Age humans carry heavy animal parts, skulls, long bones, even tusks, into difficult terrain, remote caves, or mountainous niches? What was the purpose? Mainstream archaeological interpretations offer a handful of ideas. Some suggest these were early food storage practices, a way to hide protein-rich resources from scavengers or preserve them during the winter months. Others propose the bone piles may have had symbolic significance, linked to spiritual rites, burial customs, or early totemic beliefs. After all, in many traditional cultures, the skull of an animal represents more than biology. It represents the spirit of the creature. Could these caches be proto-altars, the early expression of reverence or fear? Another possibility is that they were territorial markers. Much like modern wolves or big cats leave scent boundaries, perhaps early human groups used bone caches as warnings or declarations. This place is claimed. This prey is ours. But here, the mystery deepens. Some of these bone caches are located far from any known seasonal encampment. In others, the bones belong to species not typically hunted in the region, raising questions of transport. Why bring these bones from afar? Why hide them in such obscure places? And then there are the anomalous cases, those that don't quite fit the pattern. In the Chiquihuite Cave of Mexico, at nearly 2,700 meters above sea level, researchers found stone tools and a scattering of bones that some argue date back over 30,000 years, far earlier than accepted models of human settlement in the Americas. The cave's isolated location, difficult to reach even today, challenges the idea of it being a typical dwelling. And yet, the tools and bones suggest repeated visitation, perhaps to leave something behind. In Siberia, the famous Yana RHS site north of the Arctic Circle shows evidence of organized mammoth bone piles dating to 30,000 BC, with signs of human interaction, though not of continuous habitation. Was this a sacred site? A seasonal ritual stop? Or perhaps something else altogether? Some fringe theorists have proposed even stranger possibilities. Could these bone caches represent early attempts at preservation science? A kind of primitive taxonomy, categorizing the creatures of their world? Or might they reflect lost knowledge of how animal parts could be used medicinally, ritually, or even in ways we no longer understand? Others suggest connections to sky lore and astronomy. In some indigenous traditions, the bones of powerful animals, especially those killed under specific lunar phases or at equinoxes, are kept apart, used to read omens or guide migrations. Were these caches silent calendars of a sort, or burial grounds for the spirit of the hunt? And perhaps most provocatively, could some caches belong not to humans, but to other hominins? If Denisovans, Neanderthals, or even an unidentified human ancestor gathered these bones, what does it say about their intelligence, their social structure, their beliefs? There is one more layer to this mystery: the question of absence. In some cases, bone caches were found without the tools expected nearby. No flint, no fire, no obvious artifacts. It's as if the action of placing the bones was the only purpose, done in silence and then abandoned. Were these ritual offerings, left in hopes of influencing the natural world, asking for good hunts, fair weather, or spiritual favor? Were they mourning sites for companions lost or animals revered? Or were they memorials, marking events long forgotten, preserved only in bone? As we follow the trail of these silent graveyards, one fact remains: the Ice Age was more than an era of survival. It was a time of intention, where humans and possibly other species made choices shaped by meaning, not just need. And so we are left to wonder, in the stillness of a cave under layers of dust and time, what stories do these bones still whisper? What mind placed them there? And what message were they trying to leave behind? From quiet caves holding relics of ritual to hidden bone caches naive in their intent, our journey now pivots toward one of the greatest geological events ever recorded: the eruption of Mount Toba in Sumatra. A cataclysm so vast it left a crater lake twice the size of Manhattan. A mystery not only in its eruption, but in its echoes, and in what followed. This is the aftermath of the Toba eruption. Around 74,000 years ago, the Earth trembled. Toba unleashed a super eruption of unimaginable scale, an explosive event catalogued as VEI-8, the strongest known in the Quaternary era. Ash clouds darkened the skies, sulfur gases soared into the stratosphere, and a volcanic winter began, a cooling that models suggest may have dropped average temperatures by several degrees globally, perhaps as much as 2 to 4 degrees Celsius, with local extremes hitting 10 to 15 degrees Celsius in high latitudes. Yet for something so immense, its geological imprint is coupled with deep ambiguity. Did it wipe out life, or did humanity endure it, changed, but unbroken? Early anthropologists embraced the Toba catastrophe hypothesis, proposing that the eruption nearly extinguished Homo sapiens. They suggested a human population crash, leaving only a few thousand survivors, a genetic bottleneck reflected in our reduced diversity today. Some even named it the volcanic winter that nearly ended us. But in recent decades, evidence has complicated that stark narrative. Stone tools unearthed in India, both below and above Toba ash layers, show continuity in human presence with no obvious break in occupation or technology. Archaeological sites along Africa's coast, including one in South Africa, revealed artifacts in sediment layers that straddle the eruption, but show no dramatic cultural collapse. Instead, life appears to have endured. Geneticists, too, have begun to question the narrative. Improved genomic analyses suggest that supposed population crashes occurred earlier or later than Toba, and may better align with founder effects or earlier climatic shifts rather than a single cataclysm. If the human population did survive relatively intact, what about Earth itself? Ice core measurements captured sulfate spikes believed to correspond with Toba, but climatic cooling had already begun in Greenland's record before those signatures appeared, tied to a global stadial known as GS20. The sulfate spike may not have caused the cooling, but it possibly accelerated a trend already underway, pushing an already unstable climate toward deeper cold. Modern climate models, including work from NASA and Columbia, have suggested that even an eruption of Toba's size might only lower global temperatures around 1.5 degrees C, with recovery within a few years, far from the millennium-long volcanic winter once envisioned. Yet the environmental aftermath appears to have been complex, mediated through atmospheric feedback loops and glacier ice interactions that could extend the effects over decades or longer. So what is the story we can piece together? First, the Toba eruption was real and global. Ash has been identified in Lake Malawi, marine sediments off India's coast, and ice cores from both poles, demonstrating its reach. Its collapse created Lake Toba as we know it today, a massive caldera now flooded by a lake that belies the eruption's original violence. Second, its biological impact is uncertain. While other species show genetic bottlenecks around 70-50 K, human populations seem not to have undergone a crash uniquely tied to Toba. Homo sapiens, Neanderthals, Denisovans, all persisted through the period, their genetic lines continuing without evidence of extinction or collapse magically aligned with the arc of volcanic fallout. Third, its environmental footprint combined with broader glacial cycles, transition from MIS-5 to MIS-4, and pre-existing climate cooling may have created conditions ripe for rapid glaciation, ecosystem upheavals, and human adaptation, but perhaps not global annihilation. Yet beneath the data lies a deeper mystery. If the eruption did not end humanity, why did so many sophisticated cultures decline soon after? Why do we see abrupt changes in settlement patterns, subsistence strategies, and material traditions across Asia, Africa, and Europe after $70,000 BC? Some archaeologists see a shift toward coastal dispersal, a strategic move to reliable resources in the face of unpredictable inland climates. Humans retreated toward refugia, areas with stable ecosystems, and those populations later re-expanded when conditions improved. Still, the abruptness of those shifts suggests more than mere climate cooling. The timing implies a punctuated crisis. Perhaps the eruption added severity to existing stress. Others propose more speculative contours of the story. Could Toba have triggered a cascade, disrupting monsoon systems, collapsing megafaunal populations, and accelerating migration? Could it even have shifted the evolutionary course of human biology, selecting for resilience, innovation, and adaptability? If so, it might not be global extinction we carry, but refined survival. This perspective echoes the cryptic silence in some prehistoric regions, abandoned cave networks, lost technologies, cultural resets. Some whisper of lost human lineages, mythical floods, or fragmentary legends preserved in myth. Upon reflection, the Toba eruption presents a landscape of paradox, a cataclysmic event, undeniably real. Yet humans endure, adapt, and continue. The climate falters, but life persists. Our deepest genetic roots remain. So what was it really? Was Toba a near extinction that we survived by luck? A turning point that reshaped culture but not annihilated it? Or merely one node in a tapestry of events, woven among glacial cycles, tectonic shifts, and human agency? The ash has long settled. The crater lies serene. But the shadow of Toba lingers, in our genes, in our climate archives, in the gaps of archaeology that hint at abrupt change. What if the most mysterious thing about Toba is not what it destroyed, but what survived? What if humanity's legacy is not darkness, but the ability to endure? And what else, buried beneath ash and ice, awaits interpretation? From the silent burial grounds of vanished bone caches to the fiery echo of Toba's ash, our journey has traced thresholds between past and present. Now we turn our gaze to a place where time seems to fold back on itself, the vast, remote wilderness of Siberia. Here, beneath the snow and permafrost, the ice still holds the memory of a world long gone, and efforts are underway to bring it back to life. The region stretches unbroken from the Taimyr Peninsula to the banks of the Lena River. In winter, ice plains lie frozen under brilliant skies. In summer, wetlands teem with tall sedges and wildflowers. But beneath the tundra, genetic time capsules lie silent in permafrost, a scattered archive of beasts no longer living: mammoths, woolly rhinos, steppe bison, and giant horses. These were the keystone species of the Pleistocene megafaunal communities that once shaped vast grassland ecosystems, sculpting landscapes and feeding predators in an intricate web of relationships. In recent decades, scientists and conservationists have proposed an audacious idea: rewilding, the restoration of lost species to recreate Pleistocene-like ecosystems in parts of Siberia. The goal is not only conservation, but ecological revival, to bring back the functioning dynamics of an Ice Age world. The concept began modestly. In the 1990s, researchers noticed that Pleistocene grasses still grow in resilient clusters across unglaciated Siberia and Beringia. These grasses had co-evolved with gargantuan grazers, animals like Mammothus primigenius, Coelodonta antiquitatis, and Bison priscus. Without these mega herbivores, the vegetation had gradually shifted toward mosses, shrubs, and dwarf trees, trapping carbon and altering permafrost integrity. Could the return of grazing giants and modern analogs help reverse that shift? Enter initiatives like Pleistocene Park, begun in northeastern Siberia in the early 2000s. Scientists fenced off plots of tundra and reintroduced hardy herbivores, Yakutian horses, musk oxen, reindeer, bison, to simulate Pleistocene conditions. The effects were striking. Under grazing pressure, plant communities shifted. Snow density changed. Soil thaw patterns adjusted. Some permafrost began to refreeze in winter, preserving organic matter once again. Small-scale trials demonstrated that the ecosystem could be nudged toward its frozen past. But could it scale? Could this be more than ecological curiosity? Meanwhile, de-extinction discussions gained traction. Scientists began exploring advanced genetic techniques, CRISPR, genome editing, backbreeding, to resurrect genes of the woolly mammoth or to engineer an elephant-mammoth hybrid. Experiments not only involved cloning but also the restoration of key adaptations: thick fur, fat layers, and hemoglobin variants resistant to cold. The idea was to create large animals that could roam Siberia and act as drivers of a revived ecosystem. Critics raised ethical, ecological, and logistical questions. What happens if a mammoth analog escapes its enclosure? How would modern predators react? Could it spread disease to modern fauna? Yet the possibility remained seductive. If giant herbivores could return, prehistoric ecology might follow. But we must also consider the less discussed implications of rewilding. If such ecosystems can be recreated, they may help slow permafrost thaw, lock more carbon into the soil, and restore seasonal hydrology. They might also resurrect a glimpse of ancient interactions: wolves hunting steppe bisons in open grasslands, ravens scavenging megafaunal carcasses under cold skies, and grasses bending beneath hardened hooves. Yet questions persist. Can rewilding recreate the full complexity of an Ice Age biome? Without predators like the saber-toothed cats or the giant short-faced bear, can ecological balance be achieved, or is it a pale approximation? Furthermore, genetic material of extinct species beyond reconstructed mammoth genes is often degraded. Fossil DNA, while preserved in permafrost, remains fragmented and incomplete. We may never have a true mammoth, only an analog, an echo of the original, shaped by modern tools. Some speculative minds propose deeper mysteries. Could the revived systems trigger feedback loops unseen? Could restored herbivore grazing patterns alter methane emissions, snow cover, or even regional climate zones? Could the sudden return of large herbivores, even engineered ones, produce ecological memories? Changes in soil microbes, permafrost structure, or biome succession that ripple across decades? Even more speculative, what if these revived ecosystems host microbial or viral life preserved in the soils, resurrected along with the vegetation and fauna? Could we reawaken not just plants and animals, but ancient microbes, viruses, or parasites, extinct in form but alive in seed bank, waiting beneath the ground? That speculation brings us full circle. From Ice Age viruses thawing in permafrost to restored mammals reviving ancient landscape processes. Yet, for all the grandness of ambition, rewilding remains partial, uncertain, experimental. Fenced clusters in the Arctic, hybrid animals in controlled reserves, and a landscape still dominated by modern predators, climate stress, and human presence. Siberia is vast, but so is the Ice Age world it once held. Every step in Pleistocene Park raises questions. Will the grasslands endure? Will predator-prey balance emerge? Can it prevent carbon release? Or might it simply produce anachronism, a simulation rather than a revival? Even the future of restored ecosystems is ambiguous. Conservationists debate whether reintroducing megafauna helps or hinders real climate mitigation. Local indigenous communities have voiced concern about genetic manipulation of iconic species, and many scientists contend that replicating Ice Age ecosystems may distract from simpler and perhaps more effective strategies for preserving permafrost and carbon sinks. Nonetheless, the metaphor remains powerful. In Siberia, the Ice Age is not entirely lost. It lingers, etched in the earth, in permafrost, in dormant genes, in grass seeds and bison populations. And for those daring to try, it may yet breathe again. What if restoring these ecosystems does more than recapture a past landscape? What if it teaches us how Earth once sustained giant forms and how fragile that balance became? Could the rewilded tundra help us understand extinction, not as an end, but as a chapter in continuity? Might these restored beasts and landscapes hold keys to climate resilience, ecological memory, and the intertwined fate of species? And what ultimately remains hidden beneath the soil, waiting for the thaw or the seed to bring it back?